Howdy, everyone. Hope you're having a good Saturday or Sunday afternoon, morning, evening, whatever time, day, place you happen to find yourself in. How is everyone today? I see Casey hanging out, Jay, Andrew, Thomas, Plebiscide. I saw Catman. I'm not sure I've seen Catman before, so welcome if you're new. Welcome if you're not new as well. Let's see, I saw more Crabs and SBQ hanging out, chatting with Tristan in the before times. Loading up for it. Let's see. Hey, Josh. This puzzle might look familiar to you. Someone did say cat. You better be careful. There is a cat man hanging around who may further wish to confuse the elaborate cat community that takes place in Sudoku. Let's see. Hey, Florian, I see as well. Alrighty, so welcome to the stream. If you're coming from Rank's stream, I hope you had a fun time there. Hopefully we'll have more, some more fun stuff going on today. So we're going to start with this puzzle by Josh Johnson. If you want me to do your puzzle, one of the easiest ways to arrange that is to put Renban and black dots in it. I really enjoy the black dot, especially the black dot Renban combo is often very exciting. So we're going to try this. So in this puzzle, we have these purple lines are Renban, and what that means is they need to contain a sequence of consecutive digits. So, for example, these could be 1, 2, 3, 4, 5, 6. No repeats, but they can go in any order. So again, it could go 6, 4, 2, 1, 3, 5. That would be perfectly acceptable as a way of putting those. I mean, I've always said I like Renban better than Whispers. I think Whispers are a little below black dots in my list of classic Sudoku clue types that I enjoy. But I think Renban are very, very much the top, and black dots I think are probably second. A little weird to have white dots in a Renban puzzle, since a white dot is a Renban, but I guess it'd be a little hard to communicate, like, this is not a length 3 Renban, this is a length 2 Renban, and that's a length 2 Renban. But anyway, speaking of, just in case you have no idea what this drivel I'm saying is, white dots just mean these two digits are consecutive, so it could be a 4 and a 5. And black dots mean that one of the digits is double the other. And so, for example, this could be a 9 if this was an 18. So that all works out. And yes, as Tristan says, thank you to all of our YouTube and Patreon supporters. I'll try and mention a little bit more about that later. But we very much appreciate all of you who support the channel and keep us going. And actually, today's puzzles, we're going to be doing a number of puzzles that have been requested by people from the YouTube, or from our YouTube tiers, where you can go and vote on what puzzles appear on the channel. So we had our first puzzle reach 2 votes of people wanting to see it. So we're definitely going to do the puzzle that was voted for by 2 people. And then there's another puzzle I saw that someone voted for. So there we go. Also, Josh mentioned the thing I was about to mention, which is the reason why black dots are such a cool mechanic in Sudoku is because almost all Sudoku mechanics have this problem that if you reverse 1 and 9, it doesn't change the clue. So, for example, if you're looking at a sandwich Sudoku, then if you just swapped all the 1s and 9s, it would be a valid solution. The same thing goes with Whispers and with a whole bunch of other mechanics. But it is not true that you can reverse 1s and 9s with black dots. Black dots, because of the doubling business, they disambiguate the high-lowity of everything. And so almost any constraint you could imagine, if you throw in black dots, you can get a unique puzzle without having to resort to other techniques. So they tend to be really nice. And so You can note there's this really symmetrical relationship here, where everywhere in this particular instance, as this has been set up by the setter Josh, everything is perfectly symmetric, except that black dots have been replaced by white dots, sort of rotated. This is a good way to make grids that look symmetric, because actually, sort of like, in terms of meaning, white dots and black dots have absolutely nothing to do with each other, but in terms of contrast, white dots and black dots look very nice together. White dots and black dots just also are just very pretty looking in grids, I think. All right. So, where are we going to start our lives? In this puzzle, I'm noticing all these Renbans are length 6, so every Renban needs to have a 4, 5, and a 6 on it. Oh, I see where to start. Never mind, we're going to start down here. Tristan can put a link to the puzzle in the chat. This triple black dot business, this is actually very interesting, because the triple black dot always requires that I either do 1, 2, 4 or 2, 4, 8. This is any triple black dot that's entirely contained in a row, column, or box. And so in particular, there's always a 2 and a 4 on it. There's a 2 and a 4 in the middle. And if 2 and 4 are gone, now what are these digits? Well, these digits now can't involve 1, 2, 4, or 8. So these digits have to be 3, 6 exactly. And so already we have a pair of this 3, 6 business. So now, remember, we said all of these length 6 Renban, they all have to have 4, 5, and 6 on them. Well, these digits cannot be 4 or 6. So the 4 and the 6 on this Renban, the 4 and the 6 on this Renban live in this box. And now that means the 4 and the 6 on this Renban, now they can't live here because the 4 and 6 in this box are on this Renban. So now there's a 4 and a 6 up here. And now this chases, because now there's no 4 and 6 on these two cells, so the 4 and 6 on this Renban have to be over here. And now that means there's no 4 and 6 here, so the 4 and the 6 on this Renban have to be here. And now we get a digit. Is this your digit, Judith? Because Judith in chat says that they see a digit, and I also see a digit, which is that now when I look over here, this 4, 6 sees this cell, and so this is a 3 and a 6. And so we can bring in our official digit dancing penguin. Zach, it will excitedly dance for the pair of 3 and 6. Go, Zach. Thank you, Zach. Thank you. Okay. Now, there are many people in chat pointing out many different things. So Sayori points out, and I like this one immediately, that what is this black dot going to be? Well, it doesn't have a 4 or a 6 on it. As soon as it doesn't have a 6 on it, then that means it doesn't have a 3 on it either. So it's from 1, 2, 4, 8, but it doesn't have a 4 on it either. So it also doesn't have an 8. And so that all leaves that the only thing on this black dot are, in fact, 1, 2. So this black dot up here is a 1, 2 pair. This is not a 6. I can mark because of the 3, 6 down here. Now, someone was saying something about aligning 4s. I'm trying to find the aligning 4s. 4 in column 7. Let's see. There is no 4 here, no 4 anywhere here. Got it. Okay. So yeah, so the 4 in column 7 is the point that chat was seeing right away, which is that there can't be a 4 in any of these cells, so there has to be a 4 in one of these, but the 4 in the box we know is horizontal, so that's the 4. Okay, and now because this is a 1, 2, that's an 8. That's interesting that chat saw that right away. I did not see that right away. So Tall Cat is pointing out there's no 2 on this Renban now because there's 2s up here and 2s down here. And so the 2s in columns 8 and 9 are gone. Hey, Liz, welcome. So now if there's no 2 on this length 6 Renban, that actually even further restricts it because now we're choosing 6 of the digits from 3, 4, 5, 6, 7, 8, 9. So that means we either need a 3 or a 9, and then we have everything else. So also somewhere on this Renban, we have to get a 4, sorry, we have to get a 5, a 7, and an 8 as well. I'm not going to pencil mark 5, 7, 8, but we know we need a 5, 7, and 8 on here for sure, and either a 3 or a 9. I don't know which one yet. Oh, I see. Judith explains how they saw this in a different way. So the way that Judith identified this was that the 4s in these 2 columns aligned in exactly the way that I just pointed out that the 2s do. I didn't see it that way. But these 4s aligned, which ruled 4 out of all of these cells in this box and forced the 4 there. That seems like a way I would more likely have seen it if I was doing this puzzle myself. Okay. Do I want to think more about the world now? Probably. So what are we doing? Oh, hey, David. Great to see you as always. That's a great point, Sayori. So Sayori points out that this dot is from 1, 2, 4, 8, but it's not 1, 2. Because if it was 1, 2, it would break this dot. So this is actually from 2, 4, 8, which means it always has a 4, which means there's no 4 here. The 4 is in one of these 2 cells, and there's no 4 in either of those cells either. And so if I actually fill in the candidates here, this is from 2, 4, 8. And so that means that this can't be a 4 itself, right? So this is either 1, 2, or 8. Is that right? Did I do this right? I feel like I screwed this up somehow. 4, 2, 1 works. 2, 4, 8 works. 8, 4, 2 works. Okay, no, I think this works every which way I have it written out now. Hey, Hawila. Getting great participation today. Bet cell. We can have a bet cell. Josh, do you have a suggested bet cell? If not, I will pick one using my patented Zeta bet cell technique. But if the setter has one, I will take that. Okay. We're going to choose this cell as the bet cell. So lock in your bets now. Oh, Josh says somewhere in box 1, so I'm going to move the bet cell. The bet cell's now here. Lock in your bets now. Take a guess as to the value of this cell, and if you guess correctly, you will win fame that will last a lifetime. Let's see. There's some 5s going on. You probably should not bet 1 or 2 for this cell, by the way. All right. Let's see, 4 and 6 are up here. That's not quite doing me anything. Yeah, we already used the fact that the 2s were aligned to note that this Renban is very restricted. I suppose I could pencil mark the 2s. Maybe that's the easiest way to remember this, is to pencil mark these 2s here. That might work. Let's see. What else am I supposed to do here? I'm looking at these cells that can't be things like 4 or 6. Like this can't be 4 or 6. That can't be 4 or 6. So I have to fit 2 4s and 2 6s in these cells, which doesn't seem super hard.
David Ratner
Oh, thank you,
donated
David.
$28
In honor of
Super
Ranks,
Chat.
who is seeing Doctor
In honor
Strange
of
2
Ranks,
now, the
who is
28th movie
seeing
in the
Doctor
Marvel
Strange
Universe.
2
We actually
now,
just saw
the
Doctor Strange 2 last
movie in
night,
the
which was
Marvel
excellent. I
Universe.
really enjoyed Doctor Strange 2. But multiverse stuff just always does it for me. So but it was an awesome movie. I quite enjoyed it. Oh, I am sorry for talking over Brian. And we can always do the old school trick of this cell. Yeah, unfortunately, I can't tell when the bot is talking unless chat tells me, which is perhaps a problem with Streamlabs, but not one that I know how to address. So we have this effect, which is maybe relevant, which is that this digit, if I ask where it goes in this box, well, it obviously can't go in any of these cells. But it also can't repeat on the Renban. So it actually appears on the other Renban. So this digit, whatever it is, appears on both Renban. This digit, whatever it is, appears on both Renban. It is a very limited collection of information. But that is a favorite deduction with Renban, but not one that I immediately see as being useful at the moment. Sorry, I realize I am hitting the microphone. Let's see. So, it's often a good idea to ask, so, can there be a 1? So, let's ask about 1s. So, there definitely is no 1 on this Renban, because we know this Renban doesn't have a 2 on it. And if it has a 2 on it, if it has a 1, it would definitely have to have a 2. So there's no 1 here. Is it possible that this Renban has a 1 on it? So is it possible that this Renban is 1, 2, 3, 4, 5, 6? And so in the universe where that's true, this has to be the 2 exactly. And then there's got to be a 1 in one of these 2 cells, which would put a 1 over here. None of this seems like a problem, though, as far as I'm able to tell. Hey, Nicholas. Welcome. Let's see. So Christoph says any cell that sees a full Renban line can't be 4, 5, 6. So that would be these cells can't be 4, 5, 6. So if we want to be a little gratuitous, we can do that. And then this one I know can't be 1 or 2 either. So this cell can only be 3, 7, 8, or 9. That one can't be 8. Which is interesting. And like if this is a 3 or a 7, it forces the exact contents of this. That's an interesting. Is this the reversed U, Renban, you're talking about? Yes, so far, Nicholas, I know you just got here. So far, most of our discussion has revolved around the fact that 2 is a line here, which knocks 1 and 2 off of this. And you can see we already have the 4s pencil marked on it. But in fact, yeah, all of these need 4, 5, and 6. So maybe I should ask, so since I've said so much about 4s and 6s, maybe I should ask about 5s, because I also need to fit 5s on all of these. So in, say, these cells, I need to fit 4 5s. Again, that just doesn't seem like a huge problem. Yeah, there are only 2 options for this Renban. So it has to have lots of digits on it, but I did not really think that pencil marking them was going to lead to a good time. Because it either has a 3 or a 9 on it, and then every other digit. Let's see. Tallcat says row 6, column 7 can't be a 2. Let's see. If this was a 2, what would be the problem? If this was a 2, it would rule... If this were a 2, it would rule 2 off of this entire Renban as well. In fact, if either of these is 2, it forces both of these Renban to not have 1 or 2 on them, which would make this a 1-2 pair. So this can't be a 2 because it would make this a 1. That's the problem. If this... So go on a brief journey through Tallcat's head with me. If this cell is a 2, then what happens is we've now ruled 2 entirely off of this Renban. And we've ruled 2 entirely off of this Renban. So where do 1 and 2 go in this box? Well, they have to go here. Well, if I put the 2 here, the 1 has to go here. And now, therefore, this has no value. So that's not the 2. So that was a good point. I think it was not Tallcat who said that. Tallcat said row 6, column 7 couldn't, or said something couldn't be a 5, maybe. I don't remember. I've now lost track of who actually argued that, but someone did. Let's see. So, is this the cell Tallcat was saying couldn't be a 5? Oh, Garion said that. Okay. If this is a 2, that has to be a 3 for whatever it's worth. This also can't be 5. So if this is a 5, then we need a 5 up here, and we need a 5 down here. Okay, sorry, I see it. If this is 5, this is not 5. If it was 5, we'd now need a 5 down here, and that would rule 5 entirely off of this Renban. Okay, so let's write out what this cell can be. Okay, so we already argued it can't be 2. It's not 4 or 6. It's not 5. It's not 8 either. So, and it's also not 3. So, in fact, actually, this cell can only be 1, 7, or 9. I bet there's other cells. So, like, this cell can't be 5 either. So, neither of these 2 cells is 5, for whatever it's worth. Because you can't put a 5 on a black Kropki dot. So the 5 on in this box is on a Renban. For whatever that's worth. Okay, let's see. So Christoph is suggesting counting the even digits. And noting that if this is 2, 4, 8, we've now used all the even digits. That's a really smart point, actually. So if this is 2, 4, 8, we've used all the even digits in this box. So both of these are odd. But we've also used 2 even digits up here already. So we'd get at most 2 even digits here. At most 0 even digits here. And so in total, we would have... And so in total, we'd have 2 here plus 4 here. We'd have 6. Isn't 6 enough? I think I get exactly... It's a very good point, but I think, unfortunately, we just get there. Because each of these Renban need to have 3 even digits because of the fact that numbers alternate. So I think that's a really smart thing to look at, even if it didn't quite pan out immediately. The tall cat point here about the 5s was really smart. Like, that can't be 5, and its mirror over here can't be 5. I kind of want to start highlighting cells that can't be 5, but yeah, I really like the idea of looking at this through parity and thinking about that. So if this was... Okay, I know, actually... Here's the thing I know that I don't think I... Oh, I know there's an 8 on this Renban, but I don't know which box it's in. But one of these digits is an 8. But I guess that could be down there, and the 8 for this Renban could be up here if they both had an 8, for example. So yeah, there are either 0 or 1 even digits on this part of this Renban. That's another thing that you could deduce, for example. Because there are 2 evens down here. There's only 1 more even, which goes in one of those places. Yes, I agree with Nicholas. Every Renban in this puzzle has a 5 on it. They all have 4, 5, and 6 just because they're length 6. 6 in box 8 is fixed. So 6 in box 8 is not any of these places. It's not any of those places either. Okay. So Christoph points out 6 in this box, at least to start, goes in one of these 2 places. And I'm going to guess that it can't go here for reasons that will become clear if we look at this very carefully. Yeah, so if I put the 6 here, what happens? Why does this go badly? Or is it actually the other? Maybe it's if I put the 6 here that it goes badly. Would put a 6 in row 3, column 4. So let's see. So if I put a 6 here, then I need to put a 6. So if I put a 6 here, I need to put a 6 here because this Renban needs a 6. And so now this Renban would need a 6. And it could not go here. It couldn't go here because, remember, this all started with me putting a 6 here. So it would have to go there exactly in order to put this. But that's a problem, actually. Yeah, sorry. It just can't go anywhere. Right. If this is a 6, I need a 6 here. And now this Renban needs a 6. It can't get it in any of these 3 places. It can't get it here because of the 6 in the row. It can't get it here because of the 6 in the column. And it can't get it here because of the 6 in the column. Right. So no 6 goes here. So this is a 6. That's a very cool observation. So now the 6 on this Renban goes in only one of these 2 places. And the 6 in this box goes in one of these places. Oh, well, that does it. So the 6 in this box goes in one of these places. And so what does that do? That rules 6 out of here. Again, just to repeat, why does the 6 in this box go in one of these places? It's because 6 is ruled off of these cells and can't repeat on the Renban. So this 6 going in this column rules 6 out of there, places a 6 here. Now we get a 6 over in one of these places. Which is very interesting. But I don't know what to do with it yet. Okay. So now I know one of these two cells is a 4. Because I need to put a... In fact, actually, this is a 4-5 pair. Right? No. Sorry, I don't know that. No, sorry. But I do know one of these two is a 4. Because if neither of them was a 4, well, we know these can't be 4s, and so then I'd have to put both 4s in this box, and I cannot do that. So one of these two is a 4. I'm going to mark those in green, just to remind myself. One of those two is a 4. Now, chat thinks we know which of these is a 4, but I don't see it. But chat might explicate it for us if I act inept enough. Let's see. So I thought that for a second, Jay. So I thought that these were going to be a 4-5 pair, but actually I can smuggle 5s in either of these places. I think. Like, let me put it this way. If I know that these two cells aren't 5, I don't know it. Let's see. Judith says, Garion is right. 4 in row 8, column 5, puts 4 in row 3, column 4. Okay, so if this is a 4, I definitely get a 4 in one of these places. And so that would become a 4. Well, row 9, column 5 can't be a 4 because one of the two green cells is a 4. So I guess, so here's an easy deduction, I guess. Where is 4 in this box? Well, it's not in the column with green. It's not in the row with 4. It's not in one of these two cells that sees the whole Renban, and it's not a 6. So one of these two is definitely a 4. That's the deduction. Let's see, and I can do the same thing in box 8. I probably can. Yep. So none of these are 4. That's not 4, because, again, one of those two has to be a 4. These aren't 4. So one of these is 4. Ah, that's going to do huge damage. Okay, thank you, Tristan. Yes. And so now that actually places the 4 here, which is huge, because when I place the 4 there, it comes with a 2 and a 1, which gives us a 1 and a 2, which now actually is going to place the 1... Oh, it's not quite going to place the 1, but I can never put a 1 here because it would need a 2 to go with it. So one of these two cells has to be a 1. Oh, this can't be a 1, because if this was a 1, I would need to put a 2 on this Renban, and I can't. So this is not a 1. Because if this was a 1, it would lop off the only place this Renban could ever have a 2. So in fact, that's the 1. So that's cool. Let's see. So yeah, one of these two is a 2. Okay, this I can update. This is not a 1 or a 2 anymore. Let's see. I can pencil mark this column. Seems worthwhile. Let's see. I still need a 2. I've got a 3, 4. I need a 5. I've got a 6, 7, 8, 9. I know these aren't 2. So these are both from 5, 7, 9, which is interesting. Okay. So this Renban, no, I don't know that this Renban has a 3 on it. What I know is that this Renban has a 3 or a 9 on it. I don't know which. It has every other digit other than 1 and 2. Is it a problem with this black dot if one of these is the 4? I don't think there's a reason this can't be 6, 3 that I see. There may well be a reason why it's a problem, but I don't see it yet. Let's see. Let's see. Tom says there's 2 options for how the 5s bounce around. So the gymnastics we did with the 4 6s are... So Tom's point is the gymnastics we did with the 4 6s at the very beginning of the puzzle are going to repeat with the 5s. We just don't know where the 5s are. But let's do them. So there's 2 different ways that this could go. So one of them is that one of these 2 is a 5. In which case none of these is a 5. So one of these is a 5. So none of these are a 5. So one of these is a 5. So none of these are a 5. So one of these is a 5. That's one universe. And the other universe is that instead of one of these 2 being a 5, we started with one of these 3 being a 5, which would now force one of these 2 to be a 5. Okay, green was a terrible choice since I've already used green. We'd start with one of these being a 5, so we'd get that one of these 2 was a 5, so we'd get that one of these 3 was a 5, so we'd get that one of these 2 was a 5. Okay, so either every yellow cell has every group of yellow cells has a 5, or every group of purple cells has a 5. That's Tom's point. And so in particular, this cell can't have a 5 because I know there's either a 5 here or a 5 here. So this is not a 5. Likewise, we can't have a 5 in any of these cells. We can't have a 5 in any of those cells. So that was a really cool... that was a very cool deduction. I liked that a lot. Let's see. I am being told so 4 is placed in box 6. Excellent, excellent point, best girl. So now I should ask myself, how can this cell be a 4? Well, it can't. And so since that cell can't be a 4, very good catch, this cell is our 4. So yeah, so we ruled 4 off of that Kropki. That was the point. Alrighty. Right, okay. So, now, Tom's point is even better, because remember, a long time ago, I wanted this to be a 4-5 pair, because we need to fit both a 4 and a 5 on these long Renban. And we can't put both 5s in this box. But at the time I said we couldn't do that with the 5s because these 2 cells could be 5s. However, Tom's point is the point that keeps on giving, which is that now these two cells can't be 5s because we know the 5 is in one of those 5 cells for the row. Because again, every yellow group either every yellow group contains a 5 or every purple group contains a 5. So there is no 5 here and no 5 here. And so this really is a 4-5 pair. So we'll say I psychically guessed that that was going to happen earlier. So no 4-5 pair there. So in fact, actually, that's going to also mean if I look at where 4 and 5 go in this box, one of them goes here, the other goes here. So this is also a 4 or 5. And I bet the same thing's going to happen up here. Yes, this is also a 4 or 5. Okay, so we get 2 4-5 pairs out of that. Okay. Christoph points out, I don't know if it's going to be useful, but actually this cell can't be a 5, and I'm excited by the deduction, so I'm going to explain it anyway. The 4 and 6 in this box are here, and so because of that, if this was a 5, this would have no friend. So in fact, actually, we can reduce the size of this yellow 5 region by 1. So if it's every yellow group that has a 5, then this digit has to be a 5, which seems very sus to me, but I don't know that I can completely disprove it as of yet. We will get there, I think. I think we will be able to disprove it. Let's see. I want to fill in the rest of these digits. These are not a 3, 4, 5, 6, 7, 8, 9. Are the only options for these digits. Was way cooler when there wasn't already a 4 and a 6 in this row. Yeah, probably, but it was still very cool. I liked it. It may be one of those prestige deductions. It's just there because it's cool, but it's not actually in any way necessary to the solve. We will see. Let's see. Jaleb says row 9, column 8. Can't be a 5. Right. Gorgeous again. So, again, either every purple region contains a 5, in which case this is not a 5, or every yellow region contains a 5, in which case, as Jaleb points out, the 5s for these columns are here, and this is not a 5. So this cell is actually never a 5. So this is a 7, 8, or 9, which is fascinating. So this digit is very big. Remember, I know there is a 7 and an 8 on this Renban for sure. So if this is a 7 or 8, it goes up here in this Renban. So we could ask about what the overlap between these two Renban is. How big is it? And so they definitely overlap in 4, 5, 6. Could the overlap be larger than that? And so I think the answer is it could be 1 larger than that. Oh, maybe it could be 2 larger than that. Oh, this is getting less interesting the more I talk about it. Because these digits obviously have no repeats between them. But if I wanted to smuggle one of these digits onto this Renban, I could do it there. And then I could smuggle one of these digits onto this Renban, I could do it there. So actually they could have 2 overlapping cells, I think. Uh, okay, so if this was a 6, so why can't this be? So why does that put us in the yellow universe if this is a 6? I don't immediately see it. Uh, oh, right, right, right. So I guess I would have seen it in a different order. If this is a 6, one of these two is a 5, which means neither purple nor yellow has a 5 in it, and that breaks. So that can't happen. So this can't be the 6. Uh, because of that reason. Uh, so in fact, now actually, these cells see a 4, 5, 6 triple. So they're from 1, 2, 3, 7, 8, 9. We can see if any of them end up cleaning up nicer than I fear that they're going to. I think this one loses nothing. This one can't be a 3. Yeah, that gave us a whole bunch of nada. I guess this one's almost interesting. Logan might be a smidge behind because we did just do that. This can't be a 5. Uh, sorry, this can't be a 6. Uh, so yeah, if this is so okay, so Logan says if this is a 6, then we look at what happens here. So then this has to be a 7 because it can't be a 5. So this would go 6, 7, 8. Oh yeah, damn 7, always screwing us up. But yeah, the 6 always goes with a 7. So one of these two digits is a 7. I don't know which one, but the 6 never goes with a 5 because neither this cell nor this cell can be a 5. So actually, what SPQ is pointing out wisely is that I know one of these two is a 7. So in particular, there's no 7 in these cells. So if this Renban wants a 7, it's got to get it from this box. Oh yes, thank you, Thomas. Please remember to hit the thumbs up button. It is very appreciated when you do so. Likewise, we have things like if this Renban wanted to have a 1 on it, the 1 would have to go down here. So a common thing to think about is we do need to put a 1 and a 9 in this box. Unless we put those 1 and 9 exactly in these two cells, one of these Renban is forced to be extreme, namely either 1, 2, 3, 4, 5, 6 or 9, 8, 7, 6, 5, 4. Let's see. Garian says look at the case of row 5, column 7 being a 2. Let's see. If this is a 2, now this is a 3. And so this now is 3, 4, 5, 6, 7, 8. So this would be 2 and 3. Is the problem... Okay. So, the problem is going to be with this Kropki dot. So if this is 2 and 3, this over here now has to be exactly 4, 8. Those are the only... That's the only way of Kropkiing this. So that's a 4 and that's an 8. I don't immediately see why that's a problem. I do see that if this is a 2, it forces this to be 4, 8. Now you force a 9 on the upper Renban. Right, okay, because if this is a 2, okay, so let's look at this again. Because if this is a 2, this is a 3. And so in particular, 9 is not on this Renban anymore because 3 and 9 are too far apart to Renban each other. So if this is a 2, this is a 3. And in particular, if this is a 2, there's a 9 up here. And so these are from 9, 8, 7, 5. I still am not quite seeing how this breaks. I would prefer not to have to go so far down my chain that I have to start putting pencil marks in if I can avoid it. But I'm very interested by this. Okay, so Hawila says it's not a 9. Okay, so let's look at that for a second. If this is a 9, then this would be an 8. And now, what does that do wrong? Because it forces 2 8s onto the Renban. If this is a 9... Sorry, no. If this is an 8... oh! Ha 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 ha! Yeah, that's interesting. The 8 in this cell is never an 8 because of this box. The only 3 places that 8 can go in this box are these 3. So if this was an 8, Hawila points out, this would also be an 8, which would be 2 8s on the Renban. So this is not a 9. I agree with that. And so in particular, this is either a 3 in the case that this is a 2, which is the one that Garion claims isn't happening, but I can't see it yet. Or this is a 7, in which case this is not an 8 by Hawila's point. This is a 6. So this cell is always a 3 or a 6. And so unconditionally, actually, this Renban is always from 1, 2, 4, 8. So this is never a 6. Because of this over here. So this digit here is always a 1, 2, or 8. Because of that. So that's also very interesting, this 3 or 6. So yeah, so this is 1, 2, or 8. Let's see, can I say more? So if this is 2, this is 8. We can now see in fewer steps than we could see before. I'm trying to figure out, so Garion is saying, look at, if this is 2 and this is 3, look at what happens to 8 in this box and this box. So this becomes a 9 in that interval. This is 2 and 3. This becomes a 9. Because I need to put a 9 in the box somewhere. Wait, does this become a 9? Now I've forgotten. I think that might be wrong. Well, I know the 9 goes up here in any event. And the 8. And so Then there's an 8 down here. Yeah, I still am missing some key ingredient as to why the 8 just doesn't end up down here in the instance where this is the 3. Okay, so so Garion has written this out more. So if this is a 2, this is a 3. And so the 6 in box 3 now is here. Okay. Sorry, the 6 in box 3 is here because now one of these two is the 6. Okay, so yeah, so 2 here, 3 here, puts a 6 here. And the rest of the Renban is 5, 7, 8, 9. Because we know we need to put the 9 on here. So these digits all become from 5, 7, 8, 9 in purple. But then you can't put 5, 7, 8, 9. So you can't put this anywhere. I can't follow this. I believe you, but I still don't see this, and this seems very complicated for like this seems like many steps of look ahead. I mean, I have no question that he's right. So in this universe, so Kuraban is trying to help it say row 5, column 9, that's this one. And row 6, column 9, these two cells see all of 5, 7, 8, 9. So these, so this quadruple is in this universe of 5, 7, 8, 9. So these can't be 5, 7, 8, 9 because they see all of them. I agree. And so now in particular, the point is, okay, I see it. So the point is this cell has nowhere to go in box 6 because now I have to put this cell in box 6. It's not repeating on its Renban. It's not down there. And it can't be over here. So maybe that's the way to see this to start with. This cell, where does it go in box 6? It's never going any of these places. So this cell is always from one of these places. Except it's not a 1 or a 4. So this cell is always either a 2, 7 or a 3, 6. But it's not a 2 either, because there's a 2 in the box. So in the universe where this is, so I guess, yeah, in the universe where this is a 2, then this has to be, then these two cells are the same. And that doesn't work because we would need these two cells. Yeah, okay. So I think I can explain this now in a way that is fewer steps. It's the same argument. So if you already believed the argument before, it's not going to change it significantly. But this cell has to be one of these. It's never these. In the universe where this is a 2, it's exactly that one. So these are both 3. And the thing about these both being 3 is you then can't put a 9 anywhere in this box. Because 3 and 9 don't go together on a length 6 Renban. And so that means we sort of like, by making this a 2, we remove our ability to put 9 anywhere in this box. So this is not a 2. It's a 7, and that's a 6. And so that's a 6. These aren't 6. So this isn't 7. That's not 7. That's not 7. Oh, and so this is a 5-9 pair now. So this is now a 2. It would seem. So now, yeah, I guess I need a 3 in one of these. I'm not sure quite yet where it is, but let's now fill in these cells. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this can't be a 9 for sure because this Renban now has a 2 on it. In fact, I actually know the exact contents of this Renban. Let's do it that way. The exact contents of this Renban, because this Renban can't have a 1 on it, but it does have a 2. So it's 2, 3, 4, 5, 6, 7. That's the 7. This is a 3, 5 pair. So now this Renban doesn't have a 3 on it. And so this Renban's exact contents are now 9, 8, 7, 6, 5, 4. And so that's not the 7. And so these aren't the 5 either, or the 7. These are an 8, 9 pair, so these are not 8 or 9, and so that's the 5, and that's the 7. Okay, and so that's the 9, that's the 5. This is now an 8. Let's see, these are not 5 or 7. So they are 3 and 9. And so now, as Kuraban points out beautifully, now 5s are purple. And so we know there's a 5 in one of these 2 cells, and we know there's a 5 in one of these 3 cells, and we can just lose the purple and the yellow. Beautiful observation, and good recall of our earlier calculation, so we did not have to redo that. So this is not 3 or 9. This was really cool, by the way, this sort of the way this all collapsed all at once. This isn't 6 anymore. Let's see, I did not gain a whole lot of insight into exactly what was going on with this dot. I know this is 1, 2, 4, or 8. Let's see. So let's see. Sayori says we can place 5 in row 9. Right. Beautiful. We can place 5 in row 9. And here's how. If I put 5 on this, it would need to be with a 4 or a 6, and it can't be. And these are already marked as not being able to be 5 because of the 4 5 pair in the box. So in fact, the 5 in row 9 is there. Very nice spot to Sayori. So that's the 5. So let's see. What is left in this row that could possibly go on this white dot? Not 6, 7, 8, or 9, or 5. So in fact, actually, this dot only comes from 1, 2, 3. It definitely has a 2 on it. So there's no 2 down here. Nor is there a 9 or an 8. One of these is definitely the 7 for the row. So this is not a 7. That's not a 7. While we are updating pencil marks appropriately. All right. Tristan points out this 8, 9 pair looks up here. So that's a 3 and a 9. Smart. Let's see. Can I do anything like rule a 7 off of one of these? One of these 2 could still be the 7 for the box. I was told one of these wasn't 8. Oh, this is not 8. Because if this were 8, it would put a 4 here, and this can't be 4 because the 4 is over there. This, now, Chad is pointing out, now that 3 and the 9, they resolved this. So that's a 5 and that's a 3. Let's see, this isn't a 7 anymore. Okay, so now I should look at these 2 dots. That's, in fact, probably what I should have looked at immediately. because they're either 1, 2 in this order, with that being a 1 and that being a 2. If they're not, then, so let's write this out. They're 1 and 2 in that order, and then we've got 3, 4, 5 in the row. And then the only other option is that there's 6, 7 in that order. So this cell is always a 3 or an 8. Because of that. But we actually know which, because remember, if we put 6 here, we have to put 7 here, and we're not allowed to do that anymore because of that 7. So in fact, actually, we can do even better. This is 6 and 7 and 8. So this is not 6. This isn't 7 anymore. Not 7 anymore. Let's see. Let's write out. Oh, so this is 1 or 2, just to finish off the row. So this is 1, 2, or 3, and one of these is definitely a 2. So this isn't a 2. So this is 1 or 8, which means this is 2 or 4. It's never a 1. Let's see. So that is interesting. Yeah, so one of these is... So now one of these is a 6, and that's a 6. So neither of these are 6. So now that's the 6. 6 can't go next to 5 here, so that's got to be a 7. Let's see. These over here are 3, 8, 9. That one's not an 8. It's just 3 or 9. Six in row 5 looks across, points out Jaleb. So this is not a 6. And so now this 6 is placed here. Very smart. So now that's not a 6. And now we place the 6 in the central box. Now has to go here. Also very smart. Let's see. I was looking to see if there were any other like very weak cells that we could pick at. This cell, C's 1 and 2, could be 3 or 4. Oh, in fact, actually, I know what it is. It's 4. Because where does 4 go in row 1? We know the 4's a line here, so the bet cell's not a 4. So the 4 in row 1 actually has to go here. Or, as Huila says, the 4 in box 1 has to go there for the same reason. Whichever of those you prefer. So that's a 4. Let's see. So these two cells are from... Let's see, 1, 2... They're not 2, sorry. 1, 3, 4, 5, 6, 7, 8. And 9. So yeah, so these are from 1, 3, 8, 9. Yep. Interesting. Is there any of that I can rule out immediately? Not immediately. I bet if I poke at it, I could rule out some of these combinations. But let's see if there's other lower hanging fruit. This isn't a 3 because there's a 3 looking at it. This isn't a 1 because there's a 1 looking at it. Yeah, but if I fill in row 1, then I'm going to reveal the bet cell too soon. Seems like a problem, but we can do it. If you're prepared, we can mark that this cell can only be 3 or 9. Let's see. But yeah, that was the only reason I had not filled in this row, was because it contained the bet cell. Let's see. we can go ahead and mark these now, I think. These could be 1, but not 2. But they could be 3, but they can't be 4. They definitely can be 5. They can't be 6, 7, or 8. And they maybe could be 9. Can they really be 9? If these were 9... Okay, Listesh is pointing out something interesting, which is that where does 7 go? Oh, maybe not quite. Sorry. Uh, oh, but Christoph's point has become relevant again, which is that these digits see every even. They see 2, 4, 6, and 8, so they're odd. So 3 of these digits are even. Which means that I only get 1 even in all 5 of these cells. Oh, interesting. And I had not noticed this, but in these cells, there's always an 8. And so because there's always an 8, and I need 3 evens here, that means that's all the evens. So that means these are definitely odd. They're not 1, so these are 3, 5, 7, or 9. Let's see. This one's not 7. I just really want this deduction to lead somewhere cool. I don't see how people are getting the bet cell yet. 9 in box 4 is limited to row 3. Do we know that this cell isn't 9? No 8 on the Renban. Oh, no 8 on this Renban. Okay, got it. Okay, I did not notice that, but yes. We pencil marked 8s here and 8s here. So there's no 8 on this Renban. So there's no 9 on this Renban, which means these digits are not 9, which now gives us a 1, 2, 3, 5 quad, which now means the bet cell is a 9. So that's the 9. These aren't 9. So they are a 3, 7 pair. So that's not a 3. So let's see. That's going to let us do some more Sudokological damage down the column. So let's see. So these two cells are 1, 2, 8, 9 only. Let's see. Row 1, column 4 sees the whole Renban. Yes. So these cells, remember, see the entirety of this Renban. And so in particular, this could never be... Wait. Does this even do anything? Let's see. This can never be a 1. Because if this cell is a 1, it makes this cell a 2 and rules 2 off of the entire Renban. That's what Listesh is getting at. So this is not a 1. Yes, or anywhere else on the Renban for that matter. So none of these are 1, if we wanted to mark that. Those aren't 1. One of these is 1. One of these is 1. Let's see. So the point is, this being 3 or 7 is actually very interesting. Nicholas is pointing out. Because it means this Renban is always extreme. So this Renban, because it either doesn't have a 3 on it, or doesn't have a 7 on it, this Renban always has to be 1, 2, 3, 4, 5, 6, or it has to be 4, 5, 6, 7, 8, 9. And by the argument that we just made involving this cell, this can't actually be 1, 2, 3, 4, 5, 6, because if this Renban had a 1 on it, this cell would be a 2, which would then mean this Renban didn't have a 2 on it. So therefore, this cell's not 7, it's 3, and that's 7. Which is then going to come down and place a 7 down here, which is going to now mean that this Renban actually is the 1, 2, 3, 4, 5, 6 Renban. So this is now 1, 2, 3, oops, 1, 2, 3, 4, 5. This is not 4 or 5 or 3. This cell is 1 or 2. Let's see. This cell can no longer be 3 because it sees the whole Renban, and so in particular, it definitely sees the 3 here. This is not 2, 3, or 5. This cell is not 1 or 4 or 5. So that does some amount of damage. And this Renban, remember, we actually should write in the candidates for, because that's not a 2. Remember, this Renban now is 4, 5, 6, 7, 8, 9. We already have the 6 on it, actually. So this is not a 7 either. Okay. Good talk. Let's see. This cell has just a jajillion options in it. Let's see. Row 4, column 6 is 14, not 15. 4, column 6. Oh, it's 1, 4, not 1, 5. I pencil marked badly. Yeah, I removed the wrong pencil mark. So yeah, 1, 2 hidden pair, as Christoph points out in column 4. This is the only other place a 1, 2 could go, which means this isn't a 1 or a 2. It's an 8 or 9. That 1, 2 gives us the 3 here. So that 3 removes 3 from here, makes this a 1, 2 pair. There's definitely a 3 in one of these cells. So now there's neither a 1 nor a 2 on this Renban. So there has to be a 2 on this Renban, because so now the only places for 2 in this box actually this is a 2-4 pair now. That's the key point. So in this box, where do 2 and 4 go? They only are allowed to go. Oh no, sorry, that's not true. 4 can still go here. But there is a 2 in one of these 2 cells in this box. So this is not a 2. Oh, and as Jaleb points out, 2 is now placed in row 6. There already is a 4 in row 6, by the way. I just never updated that pencil mark. But now this is the only place for a 2 within this row. So that's a 2. So that's a 1. That's a 2. That's a 1. That's a 2. This isn't 2 anymore. These aren't 1 anymore. That one's not 2 either. So that's an 8, 9 pair, which means this is the 2. Let's see. So these digits are from a very scant set of digits. They are a 1 and... No. Oh, they're a 1 and an 8 or a 9. So that gives us a 1, 8, 9 triple in row 5. So this is not 1. This is not 8 or 9. Interesting. Oh, now the 3 in this row. The 3 in row 6 is now over here. Which then lets us ask about where the 3 goes in row 5. And the 3 in row 5 now is placed here. I guess that was just the 3 on this Renban. This Renban now is done. As Kuraban points out, the 1 sees the 4. Let's try that again. The 1 sees the 4, dramatic stroke, which now sees the 5, and the 4, and the 5. So now this isn't a 4. Now this really is a 2-4 pair. That's no longer a lie. Oops. So these are no longer 2-4 businesses. So this is a 5, just by the box or whatever else you want. So these aren't 5 anymore. That's not 4 anymore. Let's see. We might have to color 8 9s in a minute, but let's pencil mark some more stuff before we resort to that. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are from 4, 8, 9. That one's not 8. That one's not 9. So these are from 4, 8, 9. So this Renban either has an 8 or a 9 on it. And if it has an 8... Wait, did I just break the puzzle? I just broke the puzzle. No, I did not break the puzzle. This Renban has a 3 on it. It does not have a 9 on it. But it can have an 8. That's fine. So 3, 9. And so now these digits are known. They had now better be 3, 5, and 7. No 9. No 9. 3, 5, 7. No 8 either. So that's the 3. That's the 5. That's the 7. Let's try again. That's the 7. So this is not a 7. And ergo, this is a 7. Let's do that's a 4, too, while we're at it. That's a 7. Let's continue with our pencil marky hoodaboo. Let's see. Still got an 8, 9 there. Let's see. I'm sure I am missing other things. Like maybe we know what this Renban is now. This 3. That's the point. This looks up at that 1, which then bounces back to that 8, that 4, that 2. That's a 9. So now this digit, I should know what it is. It's a 1. Yep. So these are a 3 and a 5. So these are a 3 and a 5. Let's try that again. And it's a resolved 3, 5. That's a 5. That's a 3. That 1 looks down, says that's a 2, and that's a 1. That 1, 9 looks over, says that's an 8, so that's a 9. That's a 1. That's an 8. That's a 9. That 8 looks down and says that's a 9 and an 8. And I think we're done. Except these have hidden from us, so that's a 9. That's an 8. Nice puzzle. Very enjoyable. I found that actually quite difficult, especially once the opening was so clear with the 4s and 6s and then bouncing all over. I thought it was going to be I thought it was going to sort of resolve all immediately, but it did not. But this is a very nice use of the various constraints. And by the way, I know at least one person bet 9. I know it was a while ago, so you might not remember, but someone bet 9. And so they are the big winner on today's stream. But yeah, that was a very cool puzzle that used lots of very, very sort of usual Renban knowledge, but in very interesting ways. Like this is a very slick puzzle. Well, I mean, once my eyes were laid on this puzzle, the odds of me not doing it on stream were low, we'll say. But yes, congratulations to Florian, who bet 9, and then the bet cell was a 9, so well done. Unfortunately, Nicholas bet -1, which was not correct in this puzzle, but maybe when we do Grockel's Puzzle Shards for our 50,000th subscriber, then maybe you can bet -1 and be correct. So yes, Looks like 25,000 subscribers, and I'll do quite a mouthful, and 50,000 subscribers, and I'll do shards. Let's say that. It is true that that resisting Renban puzzles is something that I rarely do. I forget what is the Walt Whitman quote that is like always yield to temptation because it may not pass your way again, or something like that. I think that's the quote. I think that is a good attitude to take towards puzzles with Renban in them. I mean, if anything, I think it counts more that you bet before the bet cell was chosen, because before the bet cell was chosen, 1 and 2 were plausible things, but this 1-2 pair was known when I picked this bet cell. So actually, you even picked it without having the full knowledge that you could have used to do it. All right, I'm going to take a real quick break, and then we'll be back. And we're going to do, I will preview this Glum Hippo puzzle, which has been voted on by our members. So just a quick word, if you want to support the stream, the best way to do that is subscribe to the stream and like the stream. But if you want to go beyond that, we have a couple options. So we have YouTube memberships and we have Patreon, and both of them are priced basically the same. And they both get you an escalating tier of benefits. The YouTube one also gets you the green name, like you can see 11 Ticles showing off the green name with a little windmill symbol. But they also give you the option to vote on what puzzles show up on stream, so I'll try every stream to do the most voted on puzzle. So we will, I'll do that. And also at high enough tiers, it also lets you actually submit puzzles to the stream that I'll do as long as they seem appropriate for the stream. So I know a lot of people have sort of like longed to be able to submit puzzles or whatever. So if you want to do that, you can become a member either on YouTube or Patreon. The YouTube, you just click the join button because YouTube can't name anything in a way that is predictable. And on Patreon, you can just go to patreon.com/zetamath. Again, we greatly appreciate all of our subscribers who support us at any level on any of these platforms, and you're about to see a screen with all of their names. So if you would like your name to appear, that is how you do it. We will be right back. Welcome back, everyone. Hope you're all doing well. I hope everyone who is headed off to bed because it is an absurd hour sleeps well. I know time zones are a bitch as far as trying to find good times for everyone to watch, but we'll continue with that. We'll continue to do our best. But anyway, enjoy. The VODs are always there, should you wish to partake. All right. So let's look at this Glum Hippo puzzle, which I think I was warned. I think I've forgotten, but I think I was warned that this one is harder. Which, given my previous puzzle I picked because I thought it would be easier, we'll see how it goes. So we have killer cages here in the grid. Digits can't repeat within a cage, so they're normal killer cages. They're just no repeat zones. They're like mini extra regions. And so a white diamond between two cages means the difference between the cage totals is equal to the topmost leftmost digit in the column in which that diamond appears. Okay, so the difference between the cage totals here is that digit. Excuse me. And a black diamond between two cages means that the ratio between their cage totals is equal to the topmost leftmost digit in the column and or row where the diamond appears. So the ratio of this total to this total to this total is that digit. And we'll go ahead and plop down a bet cell. This territory looks nice and empty. I think if I plop down a bet cell here, we may not find out until next stream what the value of it is. So the place that I'm inclined to start is that this cage has a total that is at least 14. So the total of this cage is actually large. Again, it's at least 14. And it's divisible by this number. Because this number has to be smaller. So the product of these two numbers is this sum. Okay, let's think. We can actually bound. I want to bound these whenever possible. So the smallest this can sum to is 14. The largest a 4-cell cage can be is 30, right? 9, 8, 7, 6. So in fact, this is min 14. This is max 30. The ratio can only be 2, right? I don't think there's any way this ratio... there's no way I have... Actually, wait. No, sorry. I think it could be 3. I think this is 2 or 3. No, I don't think it can be 3. Well, it can't be 1 because there's a given 1. So I'm using the existence of the given 1 here to rule that out. But I don't think it can be 3, because in order for it to be 3, one of these would have to be 10. It would have to be this one, because this one can't be 10. But then this one would have to be 30 with a 3 in it. And 30 with a 3 in it is not going to work in 4. So this is a 2. And so I think that means that we get to bring out Zach already. Zach was expecting a little bit more of a rest, but Zach will happily wiggle his flippers for... and shake for that. And so very excited, Zach. Go, Zach. So So Panthera made the same argument. The thing Panthera I think missed that I almost missed is I originally uh-oh, what did you say ouch for? Oh, the amount of awakeness. I missed that this could be the big cage and this could be the little cage. But even with that reverse option, it still was this. Okay. So now this number is a divisor of this number. And the product of these two numbers is the sum of this cage. So I think that's going to really restrict this number. So again, what are the options for the total of this cage? Well, it's at least 14. But we either have to be able to double it or have it. So it's at least 14. But then if we're going to double it, it's going to have to be 14 or 15. It can't actually be 14. That is sort of where I'm going with this. But I want to look at the other direction and say, what if this is the big one? If this is the big one, the maximum it could sum to is 26, and then this could sum to 13. Now, it can't actually be 26, because that would leave no value for this cell, because this cell has to be a divisor of 26. So this can't be 26. It can't be 25. It could be 24, maybe. If this were 6 and this were 4 and these two were a 7-9 pair, I think that's vaguely possible. In short, we might not be able to get this right away. Yeah, I think there's multiple ways to make the total of this being 24 and this being 12 work. Of course, my brain, because of this given one, my brain wants this to be 15, with this being 3 and 5, but I don't know that we can say a whole lot about that just yet. Okay. Now, the one in the column here is saying that this digit is consecutive with the sum of these two digits. So the sum of these two digits is at least 5, and so this is at least 4 by similar reasoning. Was trying to decide if we could use Simon's secret here, but I don't think we quite can. Okay, so the obvious, let's just think through the obvious. It's not quite an arrow, because it's an arrow that's off by 1. Because the white diamond means that's the difference. It's the difference, Amphirio. It's not the total. So the difference between these is 1. So this could be 2, 3, and that be a 4. Its ratio for black diamonds, it is difference for white diamonds, JC. Yes, if it were a black diamond, it would be saying that these were equal, but it is not. It is a white diamond. So Nicholas has a few times pointed out that these 5 cell cages are min 15. So the thing I was immediately interested in was, so that in my heart of hearts, I want this to be 15, with this being 30. But the thing that's interesting about that is, if this is 15 with this being 30, then this would have to be 2 with this being 15 again. and then this being 30 again. And this is starting to sound like something that might actually break if we chased it long enough, because 15 and 30 don't have a whole lot of flexibility. Now this one has to be at least, in fact, 21 in total. So this is at least 21, whereas this is at most this is at most 17, but I guess it could be very small. And then this could be 21. This could be this could be sum to 3. This could be 21, and this could be a 3 up here. That would be fine. People are pointing out I said it's at most 17. Technically, there's a given 8, so it's at most 16. But I don't think that changes any of the aforementioned calculus. But I kind of think that it's not actually going to be 15 and 30 now. But we'll see. Hey, Chris, welcome. Is there something you would like to do with the given 8, Nicholas? I don't think the given 8 does much as of yet that I can see. One of these is double the other. That sounds correct, Chris. 15, 20, 24, 20, 22, or 24. If this is the smaller one, it's definitely 15. If it's the bigger one, I didn't go farther than seeing that I could make 24 work. But your list seems very plausible of 24, 22, or 20. I mean, I don't know anything at all about this, right? This is an unknown difference from the sum of these two. So I don't think this 8 is going to be useful for a long time, is my prediction. But I am noticing this 1, 2. This is something my eye keeps drifting back to. Tells me that this total is actually fairly large. Wait, to a 7-cell cage. Wait, what's connected to a 7-cell cage? So this is at least 21. And so Garion is pointing out this needs to be at least 12. Is that... Am I supposed to get something out of that? So what if this is the small one? So if this is the small one, all of our pressure goes off, right? Because if this is small, if this is the small one of these two, then this is, it could even be 10. And so now this now would have to be like at least 20, and then this would so I guess actually there's a reasonable amount of pressure on this digit, because this is at least 15, looking at a number that's at least 10. So the ratio can never be the ratio could never be as large as 5, for example, because this is at least 15 going with a number that is at most 30. So the ratio, so this digit actually is quite restricted. So this is at least 15. What are the possible ratios it could have with this? I think the answers might only be 2 and 3, actually. So, because I don't think it could even be 4. Because in order to be 4, this would have to be... Yeah. In order to be 4, what would I have to do? I would have to have either... Actually, maybe it could be 4 if these two each totaled to 11. No, because then this would need to total to 44, and this can't total to 44. Because, yeah, because the maximum is 35, actually. And so the maximum ratio is 35 to 10, which is 3.5. So, yeah, so this is a 2 or a 3. Are there any similarly constrained ratios? Oh, I guess this one is very interesting. Although this one's maybe going to be constrained the other way. I think this one's going to have to be huge. Okay, so let's look at... So Garian says that their opinion is that this being 3 breaks. So if this was a 3, I would need to make a ratio of at least 15. So this would have to be the big one, because if this was the small one, then I would need to make this ratio 40. I'd need to make this sum 45 or bigger. So in the world where this is a 3, this is the big one, and it is 3 times the sum of this. So the absolute maximum that this can sum to is, I am told, 35. So then the absolute maximum that this would be allowed to sum to, if it is a third of something that is at most 35, is 11. So this would need to be either 1, 2, 3, 4 or 1, 2, 3, 5 in this universe. But the problem with this being... The problem with that is that this would have to be the same thing. So imagine that this is a 3. Then this cage totals to 33. This is 11, and this is 11. Well, now this is a 1, 2, 3, 5 triple. Or it's a 1, 2, 3, 4 triple. But that, either way, breaks this being a 3. So this is never a 3. So this is a 2. And I see people in chat have about 65 different proofs that this can't be 3. I like mine the best, but you can like whichever of them you like. I like that this would have to be a quadruple that involved 3. But whichever you want. So yeah, so this is a double. Okay, so can this still be the small one? Oh, maybe now this can't be the big one. So the point now is that this cage now can't have a 2 in it. And so the minimum sum of this cage, now that it can't have a 2 in it, is now at least 1, 3, 4, 5. And that's 14. And so if we now look back, now this being at least 14 means that now it can't be... this can't be double it, right? This can no longer be the bigger one. Because if this were the bigger one of these two... Sorry, I feel like I'm not articulating this very well. 13, actually. But 13 still doesn't work. So, sorry, I misadded that. Let me go over this again. The minimum of this cell, or the minimum of this cage, is 13. So, if this is smaller, so if purple is smaller than yellow, then that means that yellow needs to sum to at least what? Yellow needs to sum to at least 26. Now, yellow could sum to 26. If yellow sums to 26, then this would be 7, 8, 9. However, these two numbers now have to multiply together to be 26, and that's not going to be possible because the factors of 26 are 2 and 13. And so that does not work. So the whole point of all of this is that, in fact, this is the big cage. So this one I'm now calling blue is the big cage. Yes, Ben. Ben was jumping the gun on my explanation of this. But yes, 7, 8, 9, not going to work with 26. And 24 is now too small. So this is the bigger one. Now, the absolute minimum that this could sum to is 14. So this needs to sum to at least 28. But it's also maximum 40. So this cage, I just am giving them names to, or I'm giving them colors so I could talk about them. And I keep trying to give them yellow again. Okay. The yellow cage now needs to sum to at least 14 and at most 15. So this sums to 14 or 15, which means that its digits are from 3, 4, 5, 6. And now the key thing is 14 doesn't actually work because of this divisibility problem. If this is 14, then in order to make this work, I have to make the product of these two numbers equal to 14, which I can't. And so, in fact, this is 15 is the total, so it looks like this. And so this is 30, which means it has to be 6, 7, 8, 9. So now the total of this Z-shaped cage is either 15 or 60. Well, it's not 60. So it has to be 1, 2, 3, 4, 5. And Renban, maybe Inferio. A couple of people in chat were pointing out I could have done that a different way. Rather than looking at this combo, I could have looked at this combo instead to conclude that this couldn't be 14, because if this was 14, this would also have to be 14, except I can't make 14 and 5. Okay. Anyway, this is a divisor of 15 that's not 3, because it's in the box, so therefore this is in fact the 5. And that's the 3. In order to make that whole thing work out. So this is neither 3 nor 5. And it's not 2 either, because there's a 2 in the box already. So in fact, this is 1 or 4. And that's not black, so I don't learn much from it. Let's see. These aren't 6 because there's a 6 in the box already. This is a 7, 8, or 9. So that's a 7, 8, 9 triple. So I should probably write in that these digits are all small. Yeah, and so Ben points out, now we should continue. This needs to have a ratio of 2 to 1 with 15. So I need to either make these 7.5 or I need to make them 30. And 7.5 won't work because it's too small. 4 digits always sum to at least 10. So 7.5 is less than 10. So this needs to be 30 again. So we get 6, 7, 8, 9 there as well. Now that's a 6, 7, 8, 9 triple. So now these are just from 1, 2, 3, 4. For that purpose. Let's see. Maybe I think I actually want to color this. I think I'm just going to put random colors on the cages so that we can talk about them. Green, purple, at least the big ones. Orange, let's see, lower yellow. There's some more, let's see, upper red. Oh, I put the wrong digits over here. Thank you, Carl. I should put the right digits. That will make the puzzle solve better if I put the correct digits. I know these two digits are these two digits, for whatever that's worth. Oh, okay, so here's the thing. The 6 is in here. Okay, this is a very, very minor point, but it's a point nonetheless. The 6 is in those two, so the 6 is not there. These are small, so these are from 1, 2, 3, 4, 5. Not immediately useful because of all the junk down here. Hey, Ambrose, how are you? So we almost have a 1, 2, 3, 4, 5 quint in the column, but we're not quite there. Yeah, Kurabon is pointing out the 4, 5, 6 here is actually interesting because it actually means that these digits are from 1, 2, 3, 7, 8, 9. These, though, are all from 4, 5, 6, 7, 8, 9. Unfortunately, this is a white diamond, so it's telling us about the difference. Now, this total is 30. This total is at least 21. So this is the difference between these two, but it unfortunately could be bigger. Yeah, this probably can't be 4 anymore because the universe where this was 4 was when this was 2, 3. Because remember, so the deal is the sum of these two is consecutive with this one. Well, the sum of these two now is actually minimum 3, 4, which is to say it's minimum 7. So, in fact, actually, Nicholas's point is correct. This gets rid of 4 and 5 from this. Gets us another 6, 7, 8, 9 to hang out over there. It's also not 6 from the box, as Ben points out. So we'll do that. Oh, now that's interesting. So this is, Hawila points this out. This is a product. So the sum of these two digits is some absurd number. So the product of these two now has to be the sum of this yellow cage, because this number now is at least 4. And there's no way that this number is at least 4 times, sorry, that the sum of these two is at least 4 times this. That's not going to work. So, in fact, this number is going to be divided by something to get this. And so it's going to be this yellow cage divided by whatever this number is the sum of these two. Okay, this is interesting. I had not appreciated this. This total is 15. The difference between 15 and this sum is equal to this digit. Okay, so either x plus y plus x is 15, or x plus y minus x is 15, with me making this x and this y. Okay, so again, just to say that the total here is x plus y. And so the difference between x plus y and 15 is x. So either x plus y plus x is 15 or x plus y minus x is 15, but x plus y minus x is y. And so y can't be 15. So in fact, 2 times x plus y is 15. which at least tells us that y is odd. And now I can rule some of these out. So, yes, y is 15 then. That's correct. So, if this were 9, then x would need to be 3. So that's fine. If this were 7, yeah, I guess this is fine, yeah. Annoyingly. I was hoping I would get some eliminations based on this, but I don't. I don't think. Oh, I can based on 6. If x were 6, this can't be 3, because then x would need to be 6, and it can't be. So this is at least 1, 5, 7, 9. Let's see, if this were 1, x would be 7. Seems okay. Can't be 5. Ah, right. Cute. If this were 5, x would be 5. Yeah, so y and x can't both be 5. Good point. So that means that this x is actually either it's 7 if y is 1. If y is 7, it's 4. And if y is 9, it's 3. So this is either 3, 4, or 7. Can we do anything with a diamond in column 2? Maybe. Oh, very smart point by Garion. Garion points out we have a virtual 6, 7, 8, 9 quad. Garion saw that right away. That was impressive. So this cage always has a 6, 7, 8, or 9. There's either a 7 or a 9 here, in which case it has a 6, 7, 8, or a 9, or there's a 7 over here. And so there's always a 6, 7, 8, or 9 in this cage, which gives us 4 total 6, 7, 8, 9s, which means now this digit is actually... in fact, actually, 5 is just placed here through sheer force of will alone. 5 is not pencil marked anywhere, and 5 can't go there, so this is a 5. And this is just 1, 2, 3, or 4. These aren't 5. So that's a 1, 2, 3, 4 quad. This puzzle's weird. In the best possible way, by the way. This is a 1, 2, 3, 4, 5, or 1, 2, 3, 4 quad, in which the 3 is over here, so these aren't 3. So one of these is 3. So these aren't 3. Just trying to keep my mark level pencil marks up. And so these are 6, 7, 8, 9. That one's not 8. Okay, so... Oh, this is not a 2, by the way. P.S., because there's a 2 in the box, which gives us a 1, 4 pair. Thank you for that. I totally did not see that, Ben. I was busy cleaning up other pencil marks. This is a 1, 4 pair, so this isn't a 1. And this, therefore, is not a 4. So because this isn't a 1, let's do this one piece at a time. Because this digit's not a 1, this digit's not a 7. But now this digit can't be a 4, and so because this digit can't be a 4, this digit can't be a 2 times 4 is 8. This digit can't be a 7. And so that means this is a 9 and this is a 3. Means that's the 9. These aren't 9. Those aren't 9. So 3 times 9... Or sorry, 3 plus 9 is 12. Note that is indeed 3 away from 15, as we had hoped. This isn't 9 anymore. Okay, now the minimum sum here is 9. And so this must be 9. It must be 4, 5, with this being an 8. So these aren't 8, and this is 8. Oops, no, that's not what I wanted. This is 8. It means these aren't 7. Means these aren't 8. So these are a 6, 7. Okay, so we've got lots of good stuff going on now. That 8 sees up there. So this down here, this is also a 7 or a 9. Okay, these need to have a ratio of 2 to 1. This is 12. So this is either 6 or 9. Well, it's not 9, so it's 6. So that's 1, that's 4. None of these are 4 anymore. So we've got that. That 4, 5, people are pointing out correctly, completely. That's a 6 and that's a 4. We have now. This triple we can write in, almost. It is a 1. We've got a 2. We need a 3. We've got a 4 and a 5. We need a 6 and a 7. We've got an 8 and a 9. So this is 1, 3, 6, 7. These are... let's see. We've got a 1. We need a 2. We've got a 3 and a 4. We need a 5. No, we've got a 5. We need a 6 and a 7 and an 8. So these are 2, 6, 7, 8. Okay. We have an octuple in box 1 that is giving us, this is a 7, I am being told. So this is a 9, which I also, I suppose, have made evident by identifying this sextuple over here. Let's see. This difference is 8, which is interesting, although I'm not sure I immediately care. Oh, let's see. These aren't 1 anymore. Yes, that's what I wanted. That's exactly what I wanted. So 1 now is placed in one of these cells in the box. Because this is now a 2, 3, 4. So this is a 1, 5 pair. So these aren't 1 or 5. They are, in fact, a 2, 3 pair. So these aren't 2. I can get rid of this 3 corner mark. What a puzzle. This is cool. Let's see. Okay, so these digits now actually see 1, 2, 3, 5. So these digits are not 1, 2, 3, 5. So if they're not 1, 2, 3, 5, that means they're 4, 6, 7, 8, 9. Except this one's not 4 or 6 either. So this is 7 or 8 or 9. That one's lots of things. These can't be 2 or 3 anymore. Because there's a 2, 3 pair in the box, so these can't be 2, 3. Okay. I think, Kurban, I think we can actually make something out of this. So yellow is min 21. Orange is max 35. So there's no way... Oh, sorry, no, there's not a black diamond between them. I see now. These are 8 apart, I suppose. Let's see, 8 in row 6. We have an 8 in row 6. Oh, you mean we should get rid of those. Got it. Those are 6, 7, 9. That sounds true. Yeah, Garion points out, and a few other people in chat point out, that actually there's at minimum a 6 and a 7 in here. So actually the minimum of this is larger. Still, and the maximum of this is actually quite a bit lower. I said the maximum of this cage was 35, but that's clearly not correct. The maximum of this cage is, let's see, 7 plus 7, 8, 9 would be 7 plus 24 would be 31. The maximum of this cage is actually 31. Oh, but I can't put an 8 here, people are pointing out, because of the given 8. So actually, it's 7 plus 6, 7, 9, which is actually 29. So in fact, this is min 29. But unfortunately, this being 29 with this being... Oh no, this being 29, and this can't be 21, so orange can't be the big one. Orange does have to be the small one, by 1, because yellow has to be more than 21. Okay, so yellow is bigger. I don't think that got us a whole lot, but it's true. Yellow is 8 bigger than orange. But thank you for joining me on this journey. Let's see. These digits are... We need a 1, a 2, we've got a 3, and a 4. We need a 5. We've got a 6 and a 7. We need an 8. And we've got a 9, and that's not an 8. Okay. This number, which is at least 8 bigger than this number, so this number has to be at least 23, is also some big number times this. So, I mean, this certainly isn't 23. Could probably be 24. If these total to 6, that's probably fine. Can't be... Maybe it could be 25. I'm not sure. Okay. But this total is 4 or 5... Or, sorry, 4 or 5 times this total is the yellow total, is interesting. Okay, so Garion wants me to pencil mark this. Okay, so if this was a 9, this would be... This could still be 3. So I think this could be a 9 times 3 is 27. I think that's fine. So I think this really is 4, 5, 6, 7, or 9. Oh, there's a good point. Okay, so good point. So I'd said this could be 27 with that being a 9, but that doesn't actually work because this number also by this row is a multiple of 4 or 5. And I do know that yellow is bigger than this 2-cell cage, which seems silly to point out, but it's true. So this can't actually be 27. So let's write out these candidates. There's a lot of candidates. What's the most this could sum to? So what's the most yellow can be? So yellow is at most 7. I guess it's at most 35 plus 4. Yellow is at most 39. But it can't actually be 39 because it has to be a multiple of 4 or 5. So yellow is at most 36. I believe. And so these digits need to sum to something that when multiplied by 4 or 5, you get something that's at most 36. So these could sum to 9. That would be fine. But they can't sum to anything bigger than 9. So these can sum to... Yeah, these can sum to 9 at most. And on the other hand, the minimum this could sum to is, say, 24, I think is possible, in which case this could sum to as little as 6. So I think this sums to 6, 7, 8, or 9. Note if it's 6, it would have to be 2, 4 on the nose. Why can't it be 2, 4? Oh, because 2, 4 would make a quadruple. Very cute. Uh, right. Okay. So I only get one of 2, 3, and 4, and I get 0 5s. So actually, the minimum I could do is actually 2 and 6 is 8. So the total here is 8 or 9. So it could be. So it is either 2 and 6, or 2 and 7, or 3 and 6. So these are like 2, 3, 6, 7, I believe, based on whether this is going to work out to be. Okay, but does that rule out this being 5? If this is at least 8. Yeah, if this is at least 8, if this is 5, then this would need to be at least 40, and we said the maximum it could be is 39. So in fact, actually, this is a 4 and this is a 5. So now this is 4 times. So this total is now either 4 times 8, which would be 32, or 4 times 9, which would be 36. So this is 32 or 36. And as Garion points out, that gives us a virtual 2-3 pair, which is going to place the 4 here. Very, Garion is all over those, because we have a 2 or 3 down here together with that 2 or 3. That makes that a 4. So that's not a 4. These aren't 4. And let's see. So it can't be 32 because of the column 6 diamond. If this were 32, I would need to say, right, okay. If this were 32, the difference between these would be 2, and this would need to be a 2, and it can't be. Excellent point, J40. So it's not 32, it's 36, which means these two do sum to 9. Do sum to 9. This is 36. Which means the difference is 6, which places a 6 there out of nowhere, making that a 7 and a 6. Making this not a 7 anymore. None of these are 6 anymore. This is a 36, which means now this total needs to multiply together with this number to give us 36. So this number is not a 7 anymore. It's not a 5 anymore. So this is either going to be 4 times 9. Oh, it's always 4 times 9. It's just a question of, is this the 4 or the 9, and is this 4 or 9? Let's see. Are there any digits we can get rid of? Yes, this can't be a 5. If this were a 5, we need this to total to 4 or 9. If this is a 5, it can't total to 4 or 9. In fact, if this is a 1... this can't total to 4 or 9, right? If this is a 1, this can't be something that would make it total to 4 or 9. So this isn't a 1. And this being a 2 doesn't work either. Because if this is a 2, then that doesn't work. Right. And good point from Jaleb. If I actually make this a 4, I need these to sum to 9, except the way I'd make them sum to 9 is as 4 and 5. So that doesn't work. So in fact, actually, this is the 9, and then these need to sum to 4, so they're 3 and 1 in that order. So that's 5 and 1. Let's clean up our pencil marks for the following bit. So these aren't 9 anymore. That's not a 9 anymore. Let's see. This isn't a 1 anymore. That's not 9 anymore. Let's see. 7, 9. These can't be 5 anymore. Oh, in fact, they already couldn't be 5 because of that, but these are, in fact, a 2, 8 pair. Let's see. Are there any other pencil marks that I should look up? Sayori points out, by the way, welcome, Sayori. I'm not sure if I've seen you around much, but welcome. Glad to have you here. You've had a lot of really great points today. 1789 is a quad in this box, so this can't be 7 or 8. This can't be 1. This also can't be 6, for reasons that I will leave as an exercise to the reader. Okay, so this sums to 36, which means this sums to 28. So these 4 need to sum to 24. Can I figure out how to do that, killer people? I know there are many killer people in chat. If I know what this cage, if I know the exact contents of this based on the fact that it sums to 28, I will be happy to use it. I can pencil mark 8 in column 4. Yes, I can. 8 in column 4 is actually in one of those 2 cells. Beautiful. So that means these aren't 8. Very cool. Made up from 5, 6, 7, 8, 9. So this can't be a 2 anymore, right? If this were a 2, that would be a 3. These would sum to 9, and I would need these to sum to 19. That's not going to work. So this is definitely not a 2. So this is 6, 7, or 8. And so, okay, so Chad is saying the only way to make it work is as 4, 6, 7, 9, and 3. Because there's no 8 there. Okay, so the maximum these sum to is 7. And then the maximum these sum to is 976. And 976 is 13, 22 plus 7 is 29. I got one more. I got 1 degree of freedom. What did I miss? Okay, did I do that wrong? These are max 7. Oh, okay. So okay, got it. Okay, so there is 1 degree of freedom, but the point is I can't use a 5 down here because the 5 is already gone. Okay, so the maximum. Okay, so here's the key. Here's how to see this if you want to do this math in your head. The maximum I can make this is 6, 7, 9. And the maximum here would be 3 and 7. That makes this 29, which means I need to be 1 lower than maximum. Well, if I want to make these 1 lower than maximum, I need to replace a 6 with a 5, which I cannot do. So the only way I can be 1 lower than maximum is with this. So that becomes a 2 and a 3. Like that. These really are a 6, 7, 9. So this is not a 6 or a 7. Gorgeous. We have a virtual 6, 7 pair in this box, if you like. That 2 places a 3 and a 2 up here. Now that has forced there to be a 3 in my cage that sums to 9. So this is in fact a 2, 7. Just by Sudoku, there's a 3 in here now. So this is now a 3, 6 cage. So these aren't 6. So this is 6. So that's 7 and that's 6. Nothing down here is 6 anymore. This is now a 1, 3, 7 triple. So these aren't 7 either. They're a 2, 8 pair. Let's see. Let's write in the candidates across this row while we're at it. We need a 1, a 2, a 3, a 4. We've got a 5, 6, 7, 8, 9. Okay, so these are just from 1, 2, 3, 4. That one's not a 3 because it's in a cage with a 3. Okay, who knows? All right, this needs to sum to 36, and now this digit is also small. So the maximum here would be, if these were 3 and 4, that would be 7. These digits actually, let's mark up this box, because this box is also very restricted. We've got 1, 2 left. We've used the 3. We need a 4 and a 5. And a 6. No, we've got the 6. We've got the 7. We need an 8. And then we've got the 9. Okay. Do I know any eliminations off of that? Not immediately. But that means the maximum of these is 5 and 8, which is 13, 17, 20, 9 and 7 would be 36. So this is max. 36 is the only way to do this is to absolutely max it out. So let me just do that again. 9 and 7 up here is 16, 19. This would be a 4. That would be 23. And then these would be a 5 and an 8, which would get us exactly to 36. So yeah, so these are 5, 8. They're not 1, 2, 4. They're 5, 8. So these aren't 5 or 8. This is a 4. This is a 9 and a 7. So these aren't 4 anymore. So that's a 1, 2 pair. That resolves the 8, 2, cleans up that 1. Let's see, yeah, those are 5, 8. Okay, I'm doing something wrong in this row. There's too many pencil marks. These should not have 4s pencil marked in them anymore. So that is 1, 2, or 3 only. So now this difference has to be pretty large. There's no way this can be an 8 anymore. If this were an 8, the minimum this would sum to is 14. 14 is way, way, way too far away from 1, 2, 3. So this is now a 2. That's an 8. This is a 1 or a 3. So let's just go through the possibilities here real quick. Oh, this is a 2, by the way, just by Sudoku. This is not an 8 by Sudoku, if we're doing things by Sudoku these days. So if this is a 2 and a 9, that's 11. 11 would be 8 away from 3. This digit can be 8. If this is a 2 and a 7, that's a 9. This can't be 6, but it could be 7. And if this is 2 and 6... that would be 5 away from 3 or 7 away. Yeah, so there's a few different possibilities. Okay, so, let's see. I see Josh has a hard-fought win in this row. I see. I have an octuple in row 6, so I probably should not have been attempting to exhaust all the possibilities when I literally have a 7 and a 9 sitting there. So this is, in fact, a 6. We just won't talk about that. We'll just go on. So now this is either a 5 or a 7 to go with this 1 or 3. It's a 1, 3 pair. Let's see. Well, it seemed like a good thing to look at the time. Okay. This isn't a 2 anymore. Oh, we can pencil mark this column. That's probably useful. Let's see. We need a 2. We've got a 3. We need a 4 and a 5 and a 6. And we've got a 7, 8, 9. So these are from 2, 4, 6. That one's, 2, 4, 5, 6. This one's not 4, 5, or 6. So this is the 2. Also known as the 2 is placed in the column by Sudoku. But whatever. These aren't 2. This isn't a 4 or a 5. So this is a 6. Just again by Sudoku, so that's a 3 and a 6. This is not a 6. This is not a 6. This 3 looks over here, says that's not a 3. This is a 4 or a 5. So 4, 5 pair in the column. Let's see. This row doesn't have a whole lot going on left. Let's see. We still need a 1. We've got a 2, 3, 4, 5. We need a 6 and a 7. We've got an 8, and we still need a 9, actually. The 9 in this row only goes here. I feel like I have too many digits pencil marked in this row. Where did my extra digit come from? Why do I have an extra digit? Which of 1, 6... there's a 6 there. That's the 1. Okay, this is a 1, 7 pair. So that is 1, 6, 9. These digits are from... They're not 1, 2. They could be 3, 4, 5. They're not 6. They could be 7, and they're not 8 or 9. So these are only from those digits. That part is maybe not as exciting as one could have hoped for. Let's do more Sudoku other places. Like this 4, this is going to do a lot. That 4 sees that 5, that 8, and that 5. That 8 sees that 9 and that 8. That 5 sees that 4. This column already has a 2, so that's a 1 and a 2. This column has a 9 now, so that's a 1. So these aren't 1. 7, 8, 9 dooley dally. There's a 7, 9 pair in this column. 7, 8, 9 triple in this column. Yeah, digits of radius 1 away are the hardest to find. No one scans for that. Let's see. This is a 3, 7, 8, 9 for the row. It's not a 9 for that. For this. Okay, yeah, so this is a 3, 7, or 8, I believe. One of these two is a 9. I don't think that's immediately helpful. Did I ever sort out what's going on down here? I fear I did not somehow. 8 for a box. Okay, so maybe I should look at these two. Need to have a difference of 6. So let's see. If this was a 7, would that work? This would be 7, and this would total 17. I would need this to total either 11 or 23, neither of which works. If this is a 7, I can't make this diamond work. Because, yeah, if this is a 7, then these become 17, and this can't be an 11. So that's not going to work. So this is not a 7. It's a 3. Which you'd think would do more, but it did not. This isn't a 4, by the way. At some point, it became not a 4. So if this were... let's see. I'm being told I can place all the 8s. Let's see if we can do that. Can I? Let's see. Where are the last 8s? Where is the 8 in... No? I feel like I've got a little... Okay, wait. Where am I missing that I can do something with 8s? One of these is an 8. I no longer am confident in my ability to place all of the 8s. Let's just look at this, because I'm confident we can figure this out. So if this is 1, 4, and 9, that would be 13. I would need to make these sum to 19 or to less than 10. That's not going to work. So this has to be a 7. So that's an 8. That's a 9. Okay, this is not a... This is now an 8. So now this is summing to 11. So this needs to sum to 16. Sorry, no, to 17. To 17. 5, 4, 4, 5. Now that 5 means these have to be 5 apart, which means that has to be a 3, and a 1, and a 7, and a 3. These aren't 4 or 5 anymore. And the difference here was not actually that difficult once we had eliminated so many candidates that it was basically done for us. That's a 1 and a 6. That's a 1 by the column. This is a 5, so the bet cell is a 5, so congratulations if you bet 5 on this puzzle. That is a 4. That is a 7. That 7 gives us a 9 and a 7. That was delightful. I really liked that one. I didn't think any steps out of this were particularly difficult, of the ones that we found. It was just all pretty cool, and I did not feel like I had to do a lot of min and maxing, because the min and maxing was rough enough that you didn't have to do anything too untoward with it. Very cool puzzle. I like that one a lot. Alrighty. I am going to take a quick break. And then when we come back, I am going to be doing this between Sums Sudoku by puzzle by Clover, for reasons I'll talk about when I get back. But I'll be back very shortly, and then we will do more puzzles. Alrighty, welcome back. So we're doing this puzzle for two reasons. So first of all, our supporter Luda3 voted for it, so this solve is dedicated to Luda3. But my discovery of this puzzle is the other day, we were hanging out in VC1 on the Discord, and I said, hey, has anyone ever done a puzzle where it's between lines, but then the sum of the digits on the between lines is the two-digit number given by the two digits on the ends? It seemed like an obvious enough thing, so I guessed that someone probably had, but I hadn't seen it before. But then Glum Hippo, the author of the previous puzzle, in the chat was like, I'm pretty sure Clover did a puzzle like that. And well, it's a Clover puzzle, so of course I'm immediately going to do it. So now we have the Clover puzzle, where it's between lines, but the circles give you the sum of the digits on between. So just to go over between lines if you've not seen them before. So the two circles give you a bound on what digits can go on the line. So if this is a 3 and this was a 7, I would need to put only digits between 3 and 7 in these cells. So these would have to all be from 4, 5, 6. Hey, Clover, welcome. Yes, Clover, if you just showed up, I was just saying, I just dreamt up this rule set and threw out in the chat, hey, has anyone seen a puzzle with this rule set? Because it seems like the kind of thing that there's probably 4 or 5 of laying around. And Glum Hippo gave me, Glum Hippo said, oh yeah, Clover did it. And I was like, great, then I don't have to. And I could just do Clover's puzzle. So there we are. So you can see some problems with this this particular arrangement. So that's regular between lines, and this has the additional rule that the sum of the digits on the line also have to be the two-digit number made up here. But it can go in any order. So there we go. Okay. So that is the puzzle. So where do we get started? 1, 9 in column 3. Ah, perfect. Thank you, Sayori. So the first emergent rule you learn about between lines, that is the first rule that is not actually a rule, but is basically a rule, is that you can't put a 1 or 9 on a between line outside of an S-cells puzzle. Because if you put a 1 or a 9 on a between line, then you'd need a number that is less than 1 or bigger than 9 on it and we generally don't allow those. So in this column, I have to put a 1 and a 9. But as Sayori alludes to, I can only put the 1 and the 9 in these two cells. So now we can repeat and ask about 1 and 9 in column 1. So 1 and 9 in column 1 now can't be here. So now I guess 1 and 9 in column 1 is not quite good enough, right? They could go in these 3 cells. I know at least one of these two is a 1 and a 9, but that's not quite enough. Let's see. Okay, so Garion has a smart point, which is to think about this little itty-bitty between line. What is the most it could possibly sum to? And so the most it could possibly sum to is 6, 7, 8, which is 21. And that's a beautiful observation and beautiful setting, too. Okay, so the absolute maximum these digits could sum to is 21. However, that's obviously an enormous problem if you try and make the sum 21, because then I need to put a 2 and a 1 here, and then I could put approximately no digits on the line at all. Okay, so that's not going to work. That is right out. So then it can't be 20 either. So then the next highest it could be is actually 19. And so the point is, whatever it is, it's a 1 something number, which means there's always a 1 in one of these two cells. That was a really smart, quick observation by Garion. Let's see. Are there any where we can force them to sum to something that is larger than a 1 something number? Like, this can't be a 1 something number, right? This has got to be at least 2, 3, 4, 5, 6. That sounds like 20 already. So yeah, this can't have a 1 on its end, because it can't sum to... So yeah, I believe that this cannot go to something like that. So there's no 1 in either of these cells for that same reason. See, Chris is saying, so row 9, column 9 is a 1. Oh, interesting. Okay, because there's another... Oh, it could be something 1. You're right. It could be like 41 or something like that. That would be okay. Okay, so Chris points out Garion's point also applies to this line, which the first 3 times I counted it had 4 cells on it. But the last time I counted on it, I counted correctly, and it had 3. So again, the absolute maximum I could put in here would be 8, 7, 8, which would be 23. And you can easily rule out 23, 22, 21, and 20 from these cells, which means that this digit needs to be a 1, because one of these two has to be a 1, and it's not that one. So it's that one. And we'll bring out Zach to do the between line dance. Zach likes between lines because the shapes of the circles remind him of himself. So he is particularly excited by between line puzzles. So he will do the all-powerful digit dance. I'm so glad to have Zach on full time for the digit dancing penguin. Hooray! Whoop. Hooray! Hooray! There you go. Thank you, Zach. Okay, so 1 is placed in box 7 via box 8. Oh, okay, so now we can ask where 1s go in box 8, courtesy of Ben. 1's only go in one of these, and so now 1 needs to go in one of these cells. Well, it's not one of these two, so the 1 can only go here. And so now the 1 is going in one of these two cells in this box. Let's see. I am going to need a 1 in this row, and the 1 in this row now only goes in one of those two cells. No, sorry, that's not true. Don't listen to me. That could be the 1. Because that could be a 1. That was not a profound statement, but it was a statement. One of the circles in... okay, so SPQ now is looking at these two circles. And is claiming one of them has to be a 2. Let's figure out what the maximum these numbers could sum up to now is. So the maximum they could sum to is 8, 7, 6, which we already established is 21, plus 5, 4 would be 30. Well, 30 is problematic, and so anything less is going to start with either a 2 or a 1, but 1's already gone. So, in fact, whatever the sum is, it starts with a 2. Very good catch. And so now... that is gorgeous. That is gorgeous. So now Sayori asks, okay, now that we know that one of these is a 2, where is the 2 in column 3? So the 2 in column 3 now is down here, which now means in order to accommodate a 2 on the between line, I need to have a 1 on one of the ends. Well, I can't have a 1 on this end, so I have to have a 1 on that end. Gorgeous, gorgeous. This is just gorgeous setting, of course. And chat is being very, very perceptive, as usual, as well. Let's see. So I think we just figured out the other digit here can't be a 3. Because if the other digit here was a 3, then these would sum to 30, which would not work well. I don't know that I really want to pencil mark that, but sure. Okay, I guess I should pencil mark this. What is the minimum that these could sum to? So these are minimum 14. And then these are minimum 5. So 14 plus 5 is 16. So this is 6, 7, 8, or 9 to make that work. Let's see. It's not... Did I do that wrong? Oh, I did that very badly. Okay, let's try that again, but better. Okay, we're going to do it better this time. These are at least 14 plus 5, which is in fact 19, which means that this digit is at least 9. And so it has to be a 9, and that has to be exactly what happens. Okay, today is not my best day for adding. Not that any day is ever my best day for adding, but we're going to go with it. So that's the 2 by Sudoku. These aren't 2 or 3. So this is a 4 or 5 pair. So this is 3. So there's a 3 over here somewhere. Oops. These digits, actually, we can write in now. They are not 1, 2, 3, 4, or 5, so they are 6, 7, 8, or 9. These, of course, aren't 9. I mean, to be honest, Smarkus, I was never that good at adding to begin with, so... So I'd love to claim that I've forgotten and gotten worse, but I think that that would be inaccurate. So these are 6, 7, or 8. Okay. But this digit can't be 9, so this digit can't be 8. Because in order to put an 8 anywhere on the line, I would need to have I'd need to have a 9 there. 2 is also shunted over here by the same Sudoku that I used to shunt 3 over here, but then I shunted the less useful digit. So there's a 2 and a 3 here, but there's a real problem with putting 2 in either of these cells, which is that this 1 actually sees, and this is one of my favorite little between line tricks, the 1 sees both circles. And so I can't possibly put a 2 on the between line, and so because of that, I have to put the 2 in the circle. Very good spot, by the way, to whoever spotted that. Okay. So these sum to at least 13 already. Uh, so this can't be a 6 because these sum to at least 13 in order to make this digit's at least 4. So, in fact, these sum to at least 17, so this isn't a 6. So one of these is a 6. But these sum to at least 13, so this digit here can't break the bank. And so it would break the bank if it were more than 6. So this can't be 7, 8, or 9 either. So this is from 4, 5, or 6. Okay. This digit has to be rather far away from 2, just by between lineometry. Because there's 1, 2, 3, 4, 5. There's 5 digits. So if you count, you could go 2, 3, 4, 5, 6, 7. That already is enough to tell you this digit has to be an 8 or a 9. Just to accommodate this whole razzmatazz. Okay, so I believe chat is chipping away at this by noting that if this was a 7, it actually does something interesting. If this is a 7, it makes these sum to 14 because it removes 7 as a candidate. And so in order for this to be a 7, I would need to have these 14. This would have to be a 3. It can't be. So this actually can't be a 7. If this were an 8, these would sum to 13 exactly. And so this would need to be a 5, which certainly could be. That's all well and good. Sayori has a good point, which is, where is 9 in column 1? Well, remember, we long ago pencil marked this 1-9 pair here, which have continued to pay us dividends through the entire solve. But that means 9's not in any of those cells. So 9 is in one of these cells, but again, remember, it's not on a between line. So the 9 is there. I feel like we could probably figure out what the minimum this digit could be is. Like, it's got to be at least 5, but I suspect it can't be 5. Oh, yeah. Sorry. The minimum this digit can be a 7, because this between line has a 6 or 7 on it. So this is always 7 or 8, I should notice. Okay. Eight in column 3. 8 in column 3 is very powerful. Good point. Sayori, but Sayori is modestly giving credit to chat for this. 8 in column 3 only goes on this, which means that I need a 9 in one of these two cells. Well, this cell's not allowed to have a 9. So this is a 2 and a 9. The sum is 29. So that means the rest of these need to sum to 16. So those sum to 10. So that means these need to sum to 6. So that's a 4 and that's a 5. I used here the fact that Simon always calls the secret, that if I take the sum of all the digits in the column, it's 45. And these sum to 29. So therefore these had to sum to 16. What kind of puzzle would it be, really, if we did not get to talk about the secret at least a little bit? So we've got that. Let's see. So there's a 9 now here, just by Sudokology. So now where's 9 in this row? Now the 9 in this row has got to be in one of these 3 spots. Oh, actually, not there. Actually, the 9 in this row now has to go in one of these 2 spots, I believe. Let me double check that. Not on a between line, not in a column with a 9, not in a column with a 9, not on a between line, not in a column with a 9, not on a cell labeled 7, 8. So yeah, the 9 in this row now goes in one of these 2 cells. So the 9 in this box is not especially exciting, unfortunately. I have a 2, 3 that's pointed at by a 2 at some point, I am told, but I do not see it. Oh, no, it's pointed out by a 2. I see. That 2 resolves this. So that's a 3 and that's a 2. I'm not good at Sudoku. I just do it on TV. So there's a 2 up in one of these cells. Do I know that neither of these is a 1? No. I know that one's not a 1. I don't think I know this one isn't a 1 as of yet. Oh, 1 in row 5 is placed. Okay, not anywhere there, not anywhere there. So it's definitely in this box, but the 1 in this box is in one of these two places. Yep, the 1 in row 5 is placed. Very good. Whoever said that, Ben said that. Let's see. Trying to figure out. Okay, so the other digit on here is a 6, 7, or 8. So I can write these in as 1, 6, 7, 8 because I know that these would have to be at least 3, 4, 5 at minimum. Probably I could do some math to figure that out, but it's not going well today, so I'm going to put that off if I can. Oh, we do have a 6, 7, 8 triple in column 1. Good catch by Sayori. So these are 2, 3, 4, 5. I think it might be interesting because of how small these are going to sum to. Because the absolute... So the biggest? Is it the smallest? What is it? Okay, so the... Maybe it's not. I'm not sure yet. So... These... can sum to 9 and 6. And yeah, then this could be anything. Actually, this digit's already kind of big itself. So this digit, let's write in. This digit is a 4 or a 6, 7, 8. So actually the minimum these two sum to is 10. So the maximum these two can sum to is 8. So I think this can't be an 8, because if this were 5 and 6, that would be 11. This being an 8 would put us to 19. Oh, it also couldn't be an 8 because you can't put an 8 on a between line that has a 7 or an 8 as the endpoint, but whatever. We're going to roll with it and feel proud of ourselves for getting up today. Let's see. What else can we do? 2 in column 9, we are asked about. That's a good point. So because of this 2 on the end, actually 2 in column 9 just gets placed smack dab there. Thank you, Carl. So then 2 in box 6 is now... 2 in box 6 is now here because there's a 2 there. Wouldn't you know it? And then 2 in box 4 is now, is now here. Very good. That was very well spotted. So that 2 removes 2 as candidates from there, of course. So I almost know what these sum to just by math, but not quite. Okay, so it's being pointed out that neither of these ends is allowed to be 2. Is that going to tell us that one of them has to be 1, or could they really start at 3? see, the box 5 line is forced. I am told. Let's see. So if this were 6, these would be 3, 4, 5, which would be 12, which does not work. So this is not 6. I was kind of resisting doing this, but we could do it. Okay, so if these were if this was 7, these would max out at 4, 5, 6, which is 15, which is not enough. So in fact, these are a 1-8 pair, and I need to make them. Oops, I need to make them sum to 18. The max I could do is 7, 6, 5, which also is the which also adds to 18 as it would happen. So we can do that. So my reticence there was perhaps ill-posed. Okay, so these are 3 and 4, which is very interesting to have sitting on the end of this. So, so this is not a 1, as I have sort of suspected it was going to turn out to be. Because then that would make this line way unfillable. In fact, actually, this number has to be bigger than 3, and so it has to be at least 4, 5, 6, 7. So this digit actually has to be an 8 or a 9, and it can only be an 8. And now, if I think about it, if this was a 4, these would have to be from 5, 6, 7, but there's 4 of them. That's not going to work. So that's 3, that's 4. And so this is actually 4, 5, 6, 7. By the way, not a 2. On here, because 4, 5, 6, and 7, not 2, which places the 2 here, which places the 9 here, places a 3 here, because we've got a 4, 5, 6, 7 quad, so that's not a 3. That's not a 3. Now, the minimum of these two is 10 and 6, which is 16. Okay, that's not as exciting as I'd hoped. This 8, by the way, tells us that this is a 9, and gives us that this is a 1 and a 9, and gives us that this digit's a 2, while we're doing the whole Sudoku thing. 9 is placed down here, just by, again, the Sudoku thing, if you are into that. 9 now, not here. So now 9 in row 8, or 6, 7, 8 triple, whichever way you want to see it, mean that's a 9. Is that all the 1s and all the 9s? Looks like all the 9s. It's not all the 1s, actually. Why do I have 1 pencil marked on a between line? The world will never know. Let's see. So yeah, one of these two is a 1. Let's see. Oh, in this box, actually. That's cool. Okay, in this box now, 1 is in one of these two cells, which resolves the 8 and the 1 over there. I was asked about 1 in row 4, but I think I ruined it by doing it a different way. Sorry to Sayori about that. Let's see. These are 4, 5, 6, 7, 8. That's not 8. These aren't 4 or 8. They are from 5, 6, 7. These aren't 5, 6, or 7. In fact, that's not 6 or 7 either because of the 5, 6, 7 woozly boo. Oh, and it's not 5 either because of the 5, 6, 7 woozly boo. So this is a 4. Okay, how about instead of marking it as a 4, I just put it in 4s everywhere. So that's a 4. That's an 8. So that's not an 8, which means this is an 8, which means one of the circles has to be a 9. Oh. Now, these aren't 4 anymore. Now, I should probably look at this digit. It looks like a 3 to me. You can let me know if you disagree. So 3 in this box now. Oh, this box already has a 3, so I should not place another 3 in it. 3 in this box Actually, not there. So the 3 in this box is in one of these two cells. I'm glad, Kurapon. I enjoy doing them, so I am glad people enjoy watching them. Although they probably make people wonder if I've ever successfully completed a Sudoku puzzle on my own. Which I will leave as a mystery. Let's see. Okay, so these are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, this is a 1. That's too many digits, isn't it? No, maybe not. 3 in box 6. I was trying to look at 3s, and it didn't look promising. Okay, 3 in box 6 is in one of these 3 cells. I feel like I already knew something about 3s. Oh, yeah. Because of the... Right. Because of the none X-Wing on 3s. That's the point. The none X-Wing on 3s tells us that these aren't 3s, because I've already used the 3 for column 8 and column 9 here. So I've got to put a 3 somewhere in here, but not on a between line with a 3. So that's a 3. That's a 1 is the joke. So now these, take 2, these are not a 2, as I tried to put. 3, 4, 5, 6, 7, and then 8 and 9. Okay, and then this is not a 4. Okay, that is all good. I did actually finish the ones, didn't I? I did not actually finish the ones. I just kind of finished the ones. So let's actually finish the one. So that's a 1 and that's a 1. And now the ones are done. Okay. At some point here, I'm going to have to do math. And I'm really not looking forward to it, if I'm completely honest. Oh, there's a 6-7 pair here. Okay, so I think maybe the 6-7 pair is going to save me from doing math. Because that 6-7 pair is going to give me an 8 up here. And so now I just need to make these digits add to 18 or 81. I'm not sure which, 18 or 81. Let's see. So the maximum these can be is 12. So this can't ever be a 4. The maximum these two can be is 14. Okay. Did I do every pair? Oh, the maximum these two can be is 7 and 5 is 12. Yeah. And so this could be a 6. Okay. All right. But yes, I think I was largely saved. Oh, and I know what these 3 sum to. I should have noticed this immediately. Because these are 4, 5, 6, 7. 4, 5, 6, 7 sum to something. It's 22. And I need the whole thing to sum to 38 or 83. So these need to sum to 16. Well, that's not a great number. Well, I'm going to remember this. By which I mean I'm not. But these need to sum to 16. If I did that correctly. I think I missed a 2. Oh, I think I did miss a 2. Sorry, I think I screwed up my math over here on this. Okay, so yes, the 2 over here I was not counting. So the minimum that these sum to, once I actually remember that the 2 is on the between line, is 12, which means this can't be a 7. The minimum that these sum to is 11, which means this could still be a 7. And then the minimum that these sum to is 12. All right. So maybe I get some more eliminations if I poke at this enough. But yeah, you're completely right. Chat identified exactly what I did, which is to forget the 2. So these do have to sum to 16 if I did that right. 4 and 5 is 9 plus 13 sounds like 22. So these do need to sum to 16, and I think chat is telling me that I know how to sum to 16 in 3 if I can't use a 1, 2, 3. So 4, 5, 6 would get me to 15. So I have to do either 4, 5, 8, which I can't do. That's the point. There's an 8 on this end. So I have to do either 4, 5, 8, which is not possible, or I have to do 4, 5, 7. Sorry. 4, 6, 7. 4, 6, 7. Did I do that right? No, that's not right. Why did I do this wrong? Okay. So the minimum these could be, okay, let's do this slowly. The minimum these could be is 4, 5, 6. That is 15. Oh, this is even only off by 1. Why am I doing this? Okay. Somehow I thought I needed to go up by 2. This is way, way, way nicer than what I thought I was doing. Okay. Sorry. These need to sum to 16. The 3 minimum sum to 15, so I just need to do 1 higher, which would be 4, 5, 7. Okay. So that makes that a 6, makes that an 8. These not an 8. These not a 6. Nope, that was just me thinking that I needed to up the thing by 2 instead of by 1, for no particularly good reason that I could come up with if forced to in court. But fortunately, I don't think there is a Sudoku court, so I am happy about that. Okay, so these digits sum to either, let's do this carefully, 45 minus 12 is 33, minus 6 is, oh no, this is exactly the kind of math I was trying to avoid. 33 minus 6 is 27. So these either sum to 27, in which case this would need to be a 2 and a 3. Oh no, I'm including the 3 in the column. Okay, in which case this would need to be a 2, right? Let's do this again. Okay. These digits, what do they sum to, conditional on what this is? So the whole column sums to 45, but we're taking off 12 plus 6 is 18. 45 minus 18 is 35 minus 8, which is 27, which would make this digit a 2. So that's not going to work. So let's try again with this being a 7. If this is a 7, then this digit needs to be 1 more, which means it needs to be 3, which is possible. So that digit is a 3 by complicated maths. So that is a 3. Okay. Oh, and this is a 7 and a 6. I should remember to actually fill in the digits that I spend an agonizing amount of time trying to actually math out. Okay, these 2 digits are something and a something. A 4 and another 4. I think there are 4 and a 5, actually, after more careful contemplation. Let's see. Stop. Did I do this wrong? Did I not math this correctly? The rest of chat isn't yelling at me. Okay. Other people in chat seem to believe it. Okay, so let's continue then. I liked chat's claim that I could place an 8 in this box if I looked hard enough, which I believe that I can. This is a 4, 5, or a 7. Josh in chat. Amazing, amazing. I would watch it. Let's see. Okay, so these are 2, 3, 4, 5, 6, 7, 8. These are not 8. So this is 8. Let's see. So yeah, 4, 6, 7. Let's see. This row needs to be 4, 5, 6, 7. So this column is stuff. 8 plus 6 is 14. Oh, I saw in chat people suggesting that I could add up another line, and I was a bit afraid because I just added up this one. But this one I'm actually very happy to do because this needs to sum to 19. These already sum to 14, so this is a 5 and a 4. Even I can do that one. So these aren't 5. This is the 4 and the 5. And we've got a 6-7 deadly pattern that's going to get resolved by the magic of maths. So these digits are a 4, 6, and 8. Well, that one's not an 8 for sure. So this one is an 8. We have a 4, 6 pair in this row now, somehow. So these are 6. Uh-oh, did I do this wrong? I think that's right. 14 plus 5, I think that's 19. I have a 5 that's looking somewhere. Let's see, this 4 looks up there for sure. So that's a 5, 7 pair. So that's a 4. Let's see, that 4 looks over here. So this is a 5, 6, or 7. Let's see. So 1, 2, 3, 4, 5, 6, 7. Let's see. This is not a 3. So that must mean this is a 3 because I need a 3 in the box somewhere. It's probably got to be there if I understand counting correctly. Okay. Now I probably actually should look at this because I think this might all get sorted out by this line. Oh, no. No, thank you. Garion has saved me. This 5 looks up here and sees a 7 and a 6. So that's a 5 and a 4. Let's see, and that's a 7 and a 6 and a 5 and a 7. Take 2. And a 7 and a 5. And a 4 and a 5. Okay, excellent. And a 7 and a 6. And a 7 and a 5. And a 6 and a 4 and a 6. And a 5 and a 7. Okay, and now we are back to the kind of math that I am very capable of doing within 2 tries. So we want to make 2 plus 4 plus 5 plus x equal 18. So that's 16. Sorry, that's 6 and 11. I'm not going to get it in 2 tries. That's 11. So I think this needs to be a 7. 6 and 5 is 11. So this needs to be a 7 and a 6 and a 7 and a 6. Very cute little puzzle. I really liked that. That was a lot of fun. It's okay. It'll accept it even if you get it wrong. Thank you for your vote of confidence, Jay. That is always good to know. Yes, the vintage clover. I mean, you can still feel a lot of the cloverness in this puzzle. Even though I'm sure you have in many ways matured as a setter since then. But there's still a lot of clover going on. Yeah, someday maybe people will start putting solutions in. Uh, I have never actually done it myself, but maybe someday. All right. So for the last puzzle tonight, I wanted to do. I'd forgotten the whole thing. I mean, I am totally there with you, Clover. If you asked me to do a puzzle I made like two puzzles ago, I would basically be doing it cold. I don't remember. Uh, these sorts of things. But yeah, this is from like it sounds like 3 years ago or something like that. Clover, is that a rough estimate of when you made this? Like, is this pre-COVID? Is this that old? I remember how to do the break-in on red and blue, and I will remember the solve path for 2D wave particles for the rest of my life. But basically, any other puzzle of mine you ask about, I'm gonna have no idea. Um, uh, let's see. So yesterday, I saw Mark's puzzle, or I started to look at what Mark was solving, and Mark was solving this puzzle by Angelo, and I was immediately jealous of this puzzle. So I was like, I'll just do this. So sorry to those of you who watched CTC and already saw Mark solve this puzzle, unless you think, hey, it would be cool to see zetamath solve this puzzle. But I thought it looked cool. Um, and actually, despite appearances, this is not a German Whispers puzzle, just so you, if you get excited about the idea of watching me solve a German Whispers puzzle, it's not that. So this is a cool little puzzle. Okay, so here's the idea of this puzzle. So this is meant to be like a family tree. So whenever you have two cells here looking at another cell like this branch, this is the baby of these two parents. And so when two digits get together and they have a baby, they naturally pass on some of their traits. And so there are in particular two traits that we're interested in this puzzle. So we're interested in the oddness or the evenness, and then we're also interested in the high mid-lowity. And so the key thing is every cell that's a child takes one of its parents' high mid lowity and one of its parents' parity. So that is odd evenness. Okay. So here's an example just to work through to make sure that we understand what we're doing. If we have parents with 2 and 5, they can have a child with value 6. And so the reason why that's acceptable is because the 6, the baby, took its parity from the parent 2 and took its high mid-lowity from the parent 5. Okay. And so then they do a further example, which is, I think, also helpful because it is a thing a thing that would be very natural to ask about, is what if 1 and 5 have a baby? Well, if 1 and 5 have a baby, that baby has to be odd, but it could either be low or mid. And so in this case, it would have to be a 3. And so in this case, the baby 3 takes its parity from the 5 and takes its high mid-lowity from the 1. Hey, Angelo, happy to have you here. So we have the setter in the house. We're fortunate often to get setters to drop by as we do their puzzles, when we don't do them in the middle of the night, as we may have done to Glum Hippo earlier. Yeah, Angelo, as soon as I saw this rule set, I was like, man, I want to do that puzzle. So then I was like, I'm going to do it, even though Mark just did it. But whatever. We'll do that. Okay, so I think we understand the rules now. So now I have to make sure it doesn't actually matter. There's no like right side up or right side down. Glum Hippo's in the U.S. I thought Glum Hippo was from Germany. Oh, I'm sorry, Glum Hippo. I have always misassumed what country you were in. I'm not sure if that's a thing you need to apologize for, but it's true. I did misassume what country you were in. Uh, okay, so this cell, I believe, if I am reading this correctly, has parents 4 and 9. And so if I can think about it, what could it be? And in fact, both of these cells, this is true. So if they take their parity from 4, then they would need to be 8. If they took their parity from 9, they would need to be odd. And so they would need to be odd, and they would need to be 4, 5, or 6, and so they'd be 5. So I think this is a 5-8 pair. Oh, does it only inherit from above? Maybe I am misreading this. Okay, let me parents above children. Let me double check this. Okay. Oh, okay. It is okay. I missed the in the row above it. Okay, yes. So that does not work. Sorry. So no 5-8 pair for us. Only cell inheritance only goes top to bottom. There are no strange time loops going on here. Okay. So it is true though that so it is true to say that like these two children or these two parents had 4 as a baby and 9 as a baby. Okay. So what pairs of digits can have both 4 and 9? Because this 4 and 9 are siblings. Bye, Kurabon. Thanks for dropping by. Always happy to have you. So these definitely need to be 1 odd and 1 even, and 1 mid and 1 high. Yeah, so 1 odd, 1 even, 1 mid, 1 high. Okay, so in particular, they are definitely mid or high, so they're not low. So they are from 5, 6, 7, 8 at the very least. And we can do some weird stuff. Like this cell, we actually know is either even or mid. So this could only be 2, 5, 6, 8, for example. Let's see. So it is worth pointing out, and this is definitely true. Ambrose points this out. 3 is actually quite restricted in this box now. 3 can only go in one of these two cells. If 3 went here, what would this baby be? The baby would have to be, I guess, 1 or 7, both of which seem plausible to me. Okay, so we already have 1 high digit in this box. And so if this digit is also high, the last high digit goes up here. And we already have 1 mid digit in the box. So if this digit is mid, the last mid digit goes up here. Oh, sorry, 1, 7, or 9? Yeah, it could be 9. That's right. Thank you, Garion. Yes, 9 and 3 could produce a 9. Let's see. Panthera says this can't be a 6 because it has nothing in common with a 9. Wouldn't that mean neither of these could be 6? Isn't that true, though? I think Panthera's right. I think neither of these can be 6. Yeah, neither of these can be 6. I agree with Panthera. And now to the point that Jay asks, what property is this inheriting from the 3? Well, it's not low, so it's inheriting the oddness. So this is actually 5 or 7 only, which means this digit has to be even in order for the 4 to come off as an offspring, which means this is an 8, which means we get to bring in Zach. Hello, Zach. This is Zach, our digit dancing penguin. If you've not yet met Zach, he dances for our first digit every day, or every puzzle. He's very excited about it. I used to have to do the digit dances myself, but we got a professional now, so I don't have to anymore. So we now get the professional to do it. He's learning all sorts of tricks, like flipping around. Wee! Wee! Whoop! Thank you, Zach. Good job. We appreciate your enthusiasm. Shh, Panthera. Don't tell Zach. Okay. Now, this couldn't be a 7, because if this was a 7, then the 4 would need to be high, and it isn't. So this is a 5. So this isn't a 5. Okay, so I do need a 7 in one of these two, because the 8 has to inherit its highness from somewhere. And the 5 actually has to inherit its midness from somewhere, so this has to be a 6. So this can't be a 6 anymore. And the 8 is inheriting evenness as well, and 4, 6, and 8 are already gone. So this is actually a 2-7 pair for 8 to inherit from, which means that these digits are a 3-1 pair for that to work. Let's see. Okay, so this digit's definitely odd because it's inheriting oddness from both of its parents. So, oh, and it's high. Okay, so this digit is odd. So it's 1, 3, 5, or 7 or 9 because it inherits oddness from these. But it actually can't be most of those things. It can't be 1 or 3 because there's a 1-3 pair. It can't be 5 because there's no mid parent for it to inherit midness from. So this is only 7 or 9. Okay, this 6 needs to inherit its middleness from somewhere, and all of the middle digits are gone in this column. So this is a middle digit. What does row 5, column 3 inherit from 3 and from 6? Oh, sorry, row 5, column 3. Okay. Sayori is asking me to pencil mark this cell. So if it inherits its parity from 3, then it would need to inherit its high mid-lowity from 6, so it would be a 5. That doesn't work. So it needs to instead inherit... It doesn't work because there's a 5 there, by the way. So instead, it needs to inherit its high mid-lowity from 3 and its parity from 6, so it needs to be a 2. Very cool spot there. Okay. So 3... Are we going to talk about the fact that row 4, column 4 is a child of 2 siblings? That is This is a very royal family sort of family tree that we have going on here. Let's see. There's got to be a 2 over here somewhere. Uh, okay, let's see. Where is weak now? Okay, so the 6 is inheriting its middleness from here. So because the 6 is inheriting its middleness from here, it's inheriting its evenness from here. So this cell is 2 or 8. Good night, Thomas. So that's 2 or 8. And so now we can pencil mark the rest of the column. It seems like a good idea. We've got a 1, a 3, a 7, and a 9 to place in the column. Okay, so this is actually interesting. This digit is the parent of... No, this digit isn't a parent of anything, is it? No, it is. Yes, this digit is a parent of this digit. What do they have in common? Well, this digit's never a middle digit. So this digit, what does it give to this? It must give this digit its oddness. So this has got to be 5. This is great fun. I am really adoring this. Okay, so 5 gets its oddness from this digit, so it has to get its midness from this digit. So this digit has to be a 4 or a 6. Let's see. Row 7, column 5 must be odd. Right. This digit has these 2 parents. This one's even, but it's odd, so it must have gotten its oddness from over here. 1, 3, 7 are its options for oddness. Almost have a quadruple. Let's see. Oh, I do have a quadruple. If I look at all the digits in the box, I do have a quadruple. So now these digits are not 1, 3, 7, or 9. So they are from 5, 2, 4, 6, 8. Except these aren't 8s. Oh, and these aren't 5s either. So these are only 2, 4, 6s. So that was actually very useful. So now this baby is getting its oddness from this parent, so it must be getting its high mid lowness from this parent, which means it can't be a 7 or a 9. But now it's getting its high mid lowness from this parent, which means it's a 2. So none of these are 2. And now that's going to sort out a lot of what's going on up here, because now this is a 7 and that's a 2. Now this kid has to get its lowness from a parent, but it can't be that parent, because 1, 2, 3 are going in this column. So this is a 1, 2, 3. This is even, so it is 4, 6, 8. This is very cool. I generally try not to do puzzles immediately after CTC does them, but when I saw this rule set, I was like, I really want to, so I'm going to. Oh, there's more to be done down here. So that 2 also inflicts damage up there. So that's 8. That's 2. So now this digit is getting its high mid lowity from this digit. So this has to be a 7 or a 9. Wait, what? Did I do that wrong? No, that's right. It's getting its high mid lowity from this digit. It's getting its parity from that digit. Okay, so this 2 is getting its parity from that digit. So it's getting its high, mid, lowity from this digit. So this is a 1 or 3, which means that this is a 7 or a 9, because there's a 1, 3 pair in the column. So this digit is getting its parity from here. So it must be getting its high, mid, lowity from up here. There's a 2 in the box already, so this is a 1 or a 3. There's a 7 in the column already. One might notice if one is carefully attentive. So that is good. Okay. This 2 sees over here, sees that this is a 1 or 3. If I look closely and pay attention. These aren't 8 because I literally put an 8 in the box. Okay, this is a middle digit. It's not getting its middleness from here, so this is a middle digit. So there's a virtual... One of these is low, and that's the rest of the lows for the row. Because there's already 2 lows here. So one of these is a 1 or a 3. I don't know which one. Let's see. Ambrose is suggesting we investigate row 6, column 3's parentage. Meant it being a parent of 8. Oh, it is a parent of 8. That's good. Okay. Sorry, I had not appreciated this family dynamic. Yes, so this 8 down here has as parents 4 and something else. So this has to be high. This is a 7 or a 9 in order to be a parent of 8. Wait, I cannot have done that right. Oh, sorry. This also has to be an 8. Sorry. This has to be high, so it's 7, 8, or 9, but it can only be 8 because it's also a child of 2. And so a child of 2... So, yeah. So this is 7, 8, or 9 by the fact that it is a parent of 8, along with 4. But it's not a 9 because of that. And it's also not a 7 because 7 could never be a child of 2. So this is an 8. And so now 2 is giving 8 its evenness. So this has to be a high digit and can only be 7 or 9 because it can't be 8. Now one of these 2 digits is high in order to be a parent of 7, 9, but it's not a 7 and it's not an 8. So it's a 9. So one of these is a 9. And so that makes this a 7. And the other parent has to be odd as well because it's got to get that. So these are from 1, 5, 9 because they're not 3 or 7. 7 and 2 have a child. It's not high because all the highs are gone from the box. So it's odd. So it is 1, 3, or 5. It's odd, but it's also low, so it's actually 1 or 3 only, which gives us a 1, 3 pair in the row. Lets us fill in the rest of these digits. So we need a 2, a 3, 4, 5, 6, 7, 8, 9. Okay, and this is not a 2. It's not a 7 either. So this is a 5 or a 6. Let's see. Given 3 in box 4. Ah, yes, there is one of those stealth 3s. So that's a 1. That's a 3. This is a 5, 9 pair. Makes that a 6. Means none of these are 6s anymore. Means this digit is a write-in. That's a 1. I'm going to fill in while I see it. 2, 3. I think it's a 4. So these digits I can write in. We've got 1, 2. We need a 3, 4, 5, 6, 7, 8, 9. These are 3, 6, and 9. And these are 1. We've got 2 and 3, 4. We've got a 5, 6, 7. We need an 8. So this is 1, 4, or 8. Okay. 8 is never a child of 1 or 3. And 4 is never a child of 1 or 3. So this can only be 1. So that makes that a 3. And this can be any odd digit that is not 3 or 5. So this is 1, 7, or 9. Let's see. Good night, SPQ. Okay, so this needs an odd parent and it needs a low parent. Its low parent can't be here because this actually sees 1, 2, and 3. So the low parent of the 3 actually goes here and is a 1. And this is the odd parent of the 3. This is a 7 or 9, and it's not a 7, it's a 9. So that's a 9, that's a 7, that's a 5, that's a 9. Okay, so now we can fill in the rest of these cells. So these are a 4, 6, 8, if I believe my other pencil marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And this is not a 4 or 6, so it is an 8, which means one of its parents must be 7 because it needs a high parent, and it can't have 8 or 9. The 7 has to go there. Its other parent has to be even, so this is 2, 4, or 6. These are not 8. They are 4 or 6. That's a 4, 6 pair in this box for some reason. So that means that left in this box, we've got 1, 2, 3, 4, 5, 6. We only have 7, 8, 9 left in the box. This isn't a 7, by the way. It is an 8 or a 9. So it has its high parent. Do these two cells always have opposite parity? They do, because if this is 8, then this is odd. If this is 9, then this is 8. So yeah, so these always have opposite parity. So this is the parent that's giving the parity. So this is either odd or even. Let's see. Row 8, column 6 is known, I am being told. So this is... Oh, sorry, no, this is row 8, column 6. It's getting something from 7, 9. The something must be oddness. So that's a 5. So this isn't a 5. So this 3 can't be a baby of an 8. It can only be the baby of a 9 because it has nothing in common with 8. So this must be a low digit in order to give 3 its lowness. It can't be a 1 or a 3, so it's a 2. So this isn't a 2, at the very least. And so now that's a 7. That's an 8. So this is, again, an odd digit. It's not 1, 3, or 7, so this is 5 or 9. We have a 4, 6 pair in this row, so let's fill in the rest. So we still need a 1, a 3, a 5, and an 8. Well, this one's not 1, 3, or 8, so it is 5. These aren't 5. They aren't 3 either, because there's a 3 in the box. So that makes this a 3, and that a 1. And that a 3, and that a 1. Let's see. These are 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4. Yep. Okay. This is not 2 or 3, so it is 4 or 6. This is not 4 or 6, so it is 2 or 3. Oh, actually, there's a 4-6 pair in the box now, so I don't even have to worry about that. These are a 2-3 pair. So these cells we can write in, and that'll be really helpful with this 1-8, I bet. So we've got 1, 2, 3. We need a 4, 5, 6. We've got a 7, 8, and we need a 9. It would seem Tristan is cooking because our smoke detector is going off. Okay. If this were a 1, then... we could have a 9 and a 4 or 6. Okay, so I think this would work actually either way. We have another octuple. So we do. That's actually helpful. So the 7, so that's a 9 and a 7. I may have spoken too quickly when I said, oh, that's actually useful. This digit needs to be even. It's 4, 6, or 8. Oh, right. 1 is low. 1 can't be a child of any of these numbers. So this is an 8, and that's a 1, and that's a 4, and that's an 8, and that's a 6. So this is not a 6. None of these are 6 either. So the 8 needs to get its highness from somewhere, and the only high digit on offer is 9. So 9 is one of 8's parents. And the other parent has to give it its evenness. So 5 can't be a parent. So this is a 4-9 pair, making that a 5. That 4-9 pair looks over here, making this a 6, and that a 4, and that a 6, and that a 4, and that a 6, and that a 4. Let's see. This is not a 3 by the column. This is not a 5 by the column. So that is a 4 or a 6. This is not a 2 or a 5 by the column. It's actually just a 7. These aren't 7. Oops. It's frightening when they just suddenly turned red and I was not expecting it. Let's see. Okay, so 2 and 5 both have something in common with 3. 2, though, cannot be a child of 9, so there are no 9s up here, because both 2 and 5 are children of these numbers. So 3 and 6 can make 2 and 5 as babies, so that's a 9. This is a 4, 6, or 8, but it's not a 4 or a 6, so it's an 8. That's not an 8. That 4 looks up, sees that 9 and that 4. Let's see. This column is almost done. Let's finish it up. So we need a 1 and a 2. We've got a 3, 4. We need a 5. We've got a 6. We need a 7, and we've got an 8 and a 9. Okay, so this is not 7. This is not 1. This is not 2 or 5. It is only 1 or 7. Okay, this column is missing 2, 3. We've got 4. We need a 5. We've got 6, 7, 8, and we need a 9. I'm hoping that'll be more useful. That was not a 3. This one's not a 9 or a 5 or a 2. So this is a 3. That was useful. Let's see, and this is 2, 5, or 9. That one's not actually useful, but we'll do it. Let's see. I'm told there's one more 8. Let's see. Chat says there is one more 8, and it is there. Okay. So this digit needs a high parent, and the only high parent on offer in row is a 9, and so the 9 needs to go there. So that's not a 9, which makes this a 2, 5 pair, which makes that a 9. The 8 also needs an even parent, which is not going to be 4 or 8, so it is 2 or 6. The 8's offspring is not 7, 8, or 9. So the 8's offspring is even, but it's not 4 or 6. So the 8's offspring is 2, which makes that 8's parent a 6. So that's a 4 and that's a 6. That 2 looks up and gives us a 3 and a 2. Let's see. This row is missing a 1, 2, and a 5. Well, this is not a 2, so this is a 1 or a 5. The 2 needs a low parent, which is not a 3. So the low parent of the 2 is a 1. So that's a 5. That's a 2 and a 5 and a 2. And a 1 and a 7 and a 5. Let's see. And we've got in this row 2, 3. We need a 4. 1, 2. We need a 3 here. And 1, 2, 3, 4, 5, 6, 7 goes there. Awesome, awesome puzzle. A++. Loved that. Yes, absolutely. If it wasn't for the fact that Mark literally just posted a solve of this, I would make this the puzzle of the week. But I don't want to be quite that aggressive in stealing their things. But yeah, awesome idea, awesome execution, lots of fun, very smooth throughout. Yeah, the nothing was too bumpy. It took a little bit to wrap my brain around exactly how it worked, but it was very smooth once I did. And then everything just sort of branched out exactly like you would expect a family tree puzzle to do. Alrighty. Well, I mean, sometimes the new ideas are easy to set. Sometimes you get lucky. Sometimes you get less lucky. Definitely, I feel like it would be hard to guess which of the puzzles I set gave me the most consternation by just looking at the puzzles. But I can tell you for sure the puzzle that nearly broke me because it kept not quite working is the pure 159 between line puzzle that I set. Yeah, I'd say exactly that, Angelo. When you have an idea, sometimes the puzzle just creates itself, and then it's like, perfect, great. And usually if it doesn't, then I just give up. And then do something else. Alrighty, well, thanks for joining me, everyone. Again, if you have not subscribed yet, please consider subscribing. If you are still hanging out here, go ahead and put a little plus thumb on the stream, on the thing. I will. Oh, that's right. Sorry, I should not switch to that. I should wait a second to do that. But also, if you want to further support the stream, remember you have two options: patreon.com/zetamath or YouTube memberships. A lot of people ask which I prefer. I don't. Whichever is great. I am ecstatic by either form of support that you want to give. It gets you stuff like if you do the YouTube membership route, you get your name in green in the chat, and you get a little windmill, and you get access to the penguin emotes as well as the Zeta facepalm emote. But also, you can get access either way through. You can get access to the upcoming puzzles list on Discord, where you can vote on what puzzles I do. So today, almost all the puzzles I did today, I just picked out of puzzles that people had voted for. So if you want to have a sway in what puzzles I do out of the giant list of puzzles, that is a great way to do it. And you can also, at higher levels, if you want, you can submit puzzles for me to do on stream, and I will do them if they seem reasonable. You cannot just subscribe as a patron and then ask me to do quite a mouthful or shards. I will not. But any reasonable puzzles I'll be happy to do. Really, the main thing I've learned from this is there are so many cool puzzles coming out, so many great puzzles coming out every day that I could not possibly do all of them, so I have no problem with sort of like letting people's interests steer us in whatever direction people are most interested in. All right, well, that's it for now. I will see you all next time. My next stream is on Wednesday, so I will see you then. If you are one of our windmills, go ahead and vote for what puzzles you'd like to see, and I might be sneaking some more into the to-do list. But anyway, thanks for watching. I'll see you all next time.